And go! Oh, we just got the go. So I'm gonna introduce myself because I think Laurence was gonna be introducing this morning, and we're not sure where Laurence is. So hi, I'm Shelley Stahl. I'm the Vice President of Data Leadership at the American Geophysical Union. Has anybody been here previously this week? Okay, we actually have some new folks. Okay, super. Welcome. Thanks for coming. This is an incredible opportunity for hands-on learning, and I'm glad that you're here. And there are things for you to download online, but it's okay if you don't do that till later. So we're going to get started. So a little bit of background. The work that we're doing on PARSEC, the reason we're here this week, especially for the folks that are new, is there's a team of over 40 researchers, who come from 6 countries, and we're working off of one data management plan. So if I say to you data management plan, is that new? A whole new word? New? Great, okay. If you have no idea what I'm talking about so far, put your hand up. Okay, great. All right. So we're gonna start from the basics. When you go for a grant, your first grant, and it's all up to you to win this grant, most funders require a data management plan with your proposal. And what that means is it's a blue world. The sky is blue. The world is at your fingertips. And as you're experiencing the most amazing research looking into the blue sky, perfect. And does anyone know how to advance my slides? Perfect, thank you. I'm just gonna say next slide and see what happens. Some funders call a data management plan different things. So DMP, that's your acronym. We'll have an acronym slide here in a second. But we're here because our funder, the Belmont Forum, calls it a data and digital output management plan. And here's the definition they use. It's a fantastic definition. And we're talking about ensuring that, oh, no, it was good where it was. Psh. Yes, I could use the clicker, but at the moment I'm going freestyle. So someone knows that I have a problem and they're trying to find the clicker. So, but if you could advance it one more slide. Actually, I know what the next slide is. So the data and digital output management plan is something where you say to your funder, this is the data I care about. This is the software I care about. This is how I'm going to take care of it. Be a steward, curate it, make sure that it's really easy to understand, and that I am going to preserve it in a way that others can reuse it, interrogate it, learn about it. So it's a critical element of open science for you to think about, for my research, I'm going to do this. Now, for those of you who are like, well, first of all, I'm not sure what my research is, and surely no one's going to make me think through the entire research project and document that all at the beginning when I have yet to actually go hunt down data or create data. Oh, that is very true. So these plans actually evolve over time. So you document what you know at the beginning, you write that all down. The funder looks at that and says, oh, they actually have thought this through. This is fantastic. We shall fund them. This is critical for you to know now. So now you're going to say to all your friends, I actually know how to make my proposal for a grant look much better because I attended this morning's session and they told me what to do. So you're going to be, everybody's going to want you on their team now that you know this. I'm just letting you know, don't leave me, ask lots of questions, and maybe this clicker will work. This is only the pointer, not changing slides. Okay, so could somebody advance my slides, please? Bingo. Crazy. So here's some vocabulary. The DDOMP, which by the way, only the Belmont Forum uses that acronym. So you'll hear it here, but then after you leave here, it'll be like, I don't know what she's talking about. So other things, other words. So data management plan, many funders use that term. Sadly, you have to think to yourself, oh, I really should include more than just data sets. I should actually include software. I should include the images I'm using. I should include the model that I've developed in my physics work. And then software management plan as well. And what the DDOMP is all of those. It includes every single element that would go into those plans. So it's like an overarching plan. It's the master plan. This is what you want to be. You want to be the master of your plan. And I wanted to give you two definitions in case you use them interchangeably, but I actually mean them separately. An object and output. So when somebody says to you, what is a DDOMP? So the O in DDOMP is output. And the reason that's meaningful is an output is the final result of your research. So the preservation of that research, you get credit for digitally preserving your data set, digitally preserving your software. You get credit for that. Slowly but surely, all of the institutions and funders are recognizing that as a contribution to the scientific record. So you're going to be way ahead. When you graduate, when you move into your first postdoc, when you move into your first position at an institution or wherever you go, to commercial or wherever it makes sense for you, being able to publish your data sets actually contributes to your career. Now, if that's not happening right now, it will. It's coming down the lane very quickly, and we're already seeing it in the United States with a recent memo from the White House. And we're already seeing it within the European Union, and we're already seeing it in Australia. So it's coming very quickly. And frankly, Sao Paulo and Brazil are way ahead thinking about open science. So I expect that if you don't have it now, you'll have it very, very soon. So be ready, because then those things contribute to your tenure and career path. Okay, and then an object is just any digital object. So an interim product, a aggregated product, something that you're looking at over multiple months and years, you're developing it. The reason we talk about it here is, imagine, okay, has anybody ever lost or had their laptop stolen? Or you know somebody who did? Okay, there we go. Can you imagine if all of your research was on your laptop and not backed up anywhere, and you just lost your entire life? Okay, that gut feel you have right now, here's what I need you to do. If all your work, your homework, all of the research, your software is in one place, not backed up, not going to the cloud, fix it immediately. Fix that immediately. Get automatic backups in place. Your work is precious. You don't have time to repeat it. It would be a waste of funder money if you had to repeat capturing observations again. So never, don't let any of your friends do this. Say, if you don't have a backup plan in place, and it has to be automated, do not think you're doing anything manual. I have a backup drive in my bag. I've been here for a week, not really a week, it feels like a week. I've been here longer than I should. I have not backed up my laptop yet. It's not automated to the cloud. So I'm violating my own rule. But you all are amazing researchers. Do not waste your time because somebody stole your laptop. Get your stuff in the cloud today. Like don't, it's not if, it's when. It's not if disaster will happen, it's when disaster happens. So you have to be a good custodian, a good steward of your own work, of your own research. And this applies to any research team you're on. Okay, let's keep moving. Okay, so don't forget that gut feel when I said your laptop's stolen. Like, remember that gut-wrenching moment, because I need you to actually plan for that so that it never impacts you. Okay, good. All right, so here's the first page of the Belmont Forum's DDOMP. And what's really nice here is they provide enormous amount of guidance as to what needs to be done. And it's focused primarily on the preservation portion, the end of your research. So I'm finished, I'm about to publish my paper. I want to make sure that all of the data that supports my research, all of the software is placed into a preservation repository. Oh my God, I have no idea what she's saying. Those are words I've never heard in my life. Oh, why am I here? Okay, we're going to tell you. We're going to walk you through all of that. It'll all be in very new words, but you're here to actually do an amazing thing. So we'll get you through the words. Once we explain them, you'll, oh, I know what that is. Okay, so hang in there. So when we were talking about the fact that these management plans progress through time, they evolve over time, this really is a living document, and it's a way for you to track and manage your work over time. So their guidance actually allows for that. So if you're, they have a process that includes these 3 steps, and our work, of course, is already in the end at awarded, which is the largest amount of information they need, but they only ask for a minimal amount of stuff at the beginning. So it's important to know what's needed when. I'm not going to go into that detail because that could be like an all-day session, but I'm going to actually give you our document. Our document is public, it's available, and you can have it forevermore. And use the guidance that we have in there because we actually walk you through all of these steps and point you back to this, this website for the training and other training. So for those of you who missed earlier this week, PARSEC is divided into 2 teams, one working on how to think about data. We call it the Data Strand or Data Science Strand. And one that thinks about our science-based question having to do with protected areas and socioeconomic impact. And the reason that works really well for us is we have our own set of researchers that we practice on to make sure that we're actually communicating. And the neat thing about our grant is that's the purpose of the grant, is to do better with the data, with the software, reusability. And this is pretty cool because we have an opportunity to actually have a petri dish of data scientists and brilliant researchers from all over the world trying to work together to solve how to make sure a DDOMP can be implemented really well. So here we are, the data scientists on this side, talking about all these words that are like, I have no idea what she's saying. And the scientists are like, I have no idea what she's saying. So if you're in that same place, so are our researchers. So feel comfortable because you're among friends. All right. So I explained a little bit about what PARSEC is, and I give you this information because sometimes the DDOMP will be a little biased to the elements of our project, but we tried to be inclusive of any type of project, no matter what, so that it's useful for anyone. So the goal of the grant was to make sure all data is reusable. So we actually made a premise that we would not generate any new observational data. We would use existing data no matter what. And we've held to it. We're 3.5, almost 4 years in, and we've actually held to that. But that doesn't mean we didn't create any data at all. We aggregate, we synthesize, we clean, we take data sources that are out there and we transform them into a format that's useful to us. So all of that did happen, and we actually are using an enormous amount of satellite imagery, which is also another type of data. So that already is preserved, and all we have to do is point to the ones that we used. And also Google Street View, so, which is another difficult to cite repository of all of Google's pictures. So has anyone ever looked up your house on Google Street View? Yeah, okay. So we use those images. Isn't that cool? You can actually use them in a scientific endeavor. A little tricky, but yes, you can do it. See Janeth and Ali. They know all the tricks on that one. Great. Okay, so I think I said all of the others, but there is a strong requirement for any research project. You should have a code of conduct for the entire team so that everyone is playing off the same rules. and standard guidelines. So if you're walking into a research endeavor and you haven't yet seen what that code of conduct is, that means that there's a possibility that people will not follow what is intended by the team. And not, as much as we hate to say this, not everybody has the same value system, and it's really important to have that. So we have one for our project. If you've not yet experienced something like this is something to ask about. You know, maybe one of your professors has a project they've worked on in the past. They can share what the code of conduct looked like and give you a sense of what that is. And we do have, in some of our other material, we walk through elements to include on data management in a code of conduct. So if anybody has an interest in that, we can set you up. For those of you who are watching this recording and don't have an opportunity to ask that question, you can go to zenodo.org and look up the PARSEC community, PARSEC, and hunt down some of our training materials there, and it's located there. So these next few slides are going to feel overwhelming. Just run with it. I'll start to dilute it following. But I want you to realize that as a research team, there is some decision making that has to happen up front. So take a look at what the requirements are for your funder. We're going to use the Belmont form because they have such a broad set of requirements that whatever they've worked through is likely going to be included in your funder. So there's a high probability that they are a superset of all of the possible funder requirements. And that helps with training because then you'll be like, oh, I know what to do. We did that in that fun workshop that I went to on a Wednesday morning, watching the lady in pink talk. Yes, I remember that. So what you want to do is actually kind of, instead of in your mind, don't think of it necessarily as a plan. Think of it like a workbook. This is something that you're going to continue to update, continue to add to. So you want to actually create one for your team. And you're also going to create a checklist. So you want to consider two things: the time of your research and as it evolves, as well as the end of your research or milestones where you want to preserve the project. Let's keep going. Is that it? Yep, okay. Here's our workbook. This is our DDOMP in Zenodo. If you look DDOMP in our Zenodo community, you will literally find this. This is what it looks like, and you can have it. It's one of our most downloaded documents, by the way. That means it's valuable, I think. Numbers tell. But you are welcome. It's open and available to you, and you're welcome to start there and have that in your back pocket. Check back every once in a while because we do update it. As a matter of fact, when I looked at these slides and Nicole was with me, the actual current version is 2021, not 2020. So this image is actually old, but it'll lead you to the new one. Zenodo allows for version control. So if you go here, it'll tell you there's a new version. Go to the new version. And we actually have a couple things we have to add to it. So if you want to know more and want to stay in touch, you're certainly welcome to email and say, what did you plan on adding that you didn't put in there? And by the way, it's seriously humorous. It's some basic stuff that we missed, and we realized it by happenstance. So has anyone heard of the FAIR guiding principles? Okay, we have one overachiever down here. Okay, great. So if you were here earlier during the week, you would have heard about it. So Belmont, in their brilliance, and my funder's in the room, so if I seem like I'm being over excessive about how awesome Belmont is, just let me have that space. Yeah. Yes, there's a funder in the room, people, right here. Just get to know her. Right there. They defined how to handle data sets at the same time as the seminal paper on how to handle data sets was being developed. So the FAIR Guiding Principles, which, by the way, you should all read, it was published in 2016. It is a North Star walking the broad research community towards better data management, data stewardship, which data being all digital objects, software, et cetera, models, forcing factors, all of that. But their definition aligns, and they did an amazing job capturing the essence of why data sets are really important. So for all researchers, I would direct you, so if you're not going to be funded by the Belmont Forum, which let's hope you are, they are having an opportunity for the, around the Amazon forest, by the way, so get ready. There is the FAIR guiding principles. So I don't have a citation up for that. I'm feeling terrible. Like on my computer, if I type FAIR, that comes up. It's a Nature paper. So go to Nature, hunt for FAIR guiding principles, and download it and read it. And then when somebody says to you, do you know what FAIR is? Yes. And that's when all the letters are capitalized, right? It's an acronym. It's not like be fair, play nice. No. FAIR data, findable, accessible, interoperable, reusable. So they align with the Belmont Forum requirements. There we go. This is the table of content of our DDOMP. I don't think you can read the bottom, but there are 20 pages. Holy moly, Shelley, you're telling me I have to write a 20-page document? That's more pages than they allow me to put in for the proposal to start with. Okay, good. Good you're with me. Carry on. Don't worry. I think I'm just going to let that sit right there because I'm going to dissect the pages for you. So the very first thing you have to do is decide who's in charge of the DDOMP. Who do you think should be in charge of the DDOMP? Somebody else? People are pointing to the guy next to them. This guy over here. So you would think it's the principal investigator, right? Like, principal investigator should do this. Okay, great. I agree. Who do you think actually is in charge of cleaning the data, getting the data to work, making the data interoperable? Who do you think does that part? Jeanette, Ali. And those are our postdocs for our PARSEC project. So 90-some% of the time, as a postdoc, you're the stuckey on doing stuff with data. So you actually want this document like completely absorbed into your brain, because what the PI will do is say, you figure it out, let me know the answer, and that's what you should do. Run, you're like, yes. Remember the woman in pink, she was talking about how to do this. I'm gonna go find that recording. She said everything I needed to know, and she gave me all the links to where stuff is. That's perfect. Yes, please do that. Please do that. Or anyone who walks you through a DDOMP, there's some really good training out there as well. So if you can't find me, that's fine. There's lots of really great people as well. So now the second part of the DDOMP, we did you a favor. We wrote down how to make decisions, and we call them operational procedures. So that whole section coming after that is a lot of text, which isn't the answers, but it does include the answers, but how, in fact, to think about getting to the answers for your project. So even though our answers are in here, we give you the answer key, our answers may not make sense to you because we had a particular kind of project, but you can see how we thought about it. Ha ha. And then this is the checklist that we handed to the researchers and said, here, use these resources. Use these tools, these resources, and at these moments in time, you have to check and make sure you're following the right guidance. And it's 1 page? It's 1 page. Okay, maybe 2 pages, but it's short. It's very short. It's not 20. So you spend time, you get to 20 pages of decision making. You do that pretty much once, although you want to double check it every once in a while to make sure it makes sense, because we actually added in different types of digital objects that we hadn't thought about at the beginning. So we had to think about them, added that in, and then kept going. It was easy. That's it. 3 parts, okay? Most of it's directions. So 20 pages, but whew, directions. Okay, that's not so bad, right? Okay, I can handle that. It's in English though, but I think you can just put it into a translator. Janeth, we should think about translating it. Where's Janeth? Not here. Ollie, we should think about translating it. I have 2 postdocs. Actually, yes. All right. So here's an example of an operational procedure. Do I have that? Yes, I do. Okay. So these are the number of these are the operational procedures. There's no way you're reading this. Don't worry. Don't try. These are the procedures that we have in place to do this and do that and do this and do that. Things with data, things with software during the project, after the project. Got that? It's like a little dance. And then the very first one is, what am I going to preserve? Oh, you haven't even done the research yet. Best of luck, buddy. This is best guess. So for the type of research, probably your supervisor, they're going to have a better sense of what the end product is going to look like. Use that experience. Don't think you've got to make it up on your own. Go find people, what did you do? And if somebody says to you, okay, beware. If somebody says to you, here, I've already done a data management plan, just submit mine. Oh, they didn't go to the training. Be aware. They have no idea. You're going to look at it and you're going to say, but it doesn't look anything like the 20-page document Shelley gave me. Oh, yes. You can actually help them. You can say, no, that is not a useful document. That is just something that gets dust on the shelf. No, we need a useful document. That's what you want to say. Now, mind you, most of you are going to, some, I'll go with some, many, let's go with many. That's more vague, right? Many of you are going to pick a research path and mostly stay on that path. You'll wiggle around, but so when you make all of these decisions, because the decisions matter on country, institution, your funder, your publisher, when you're walking through what data sets go where, that will still apply to your next research project, mostly. So once you do one of these, you actually have a template that you can use for your next one. So first time, thinking is deep. Second time, easier. Third time, way easier. And frankly, if you have someone who's already done this on your team, you can take the one from the team and use that as a guide. So really, you just have to put energy up front, and then the rest of your life gets a lot easier. Nice, right? I got you. Okay. Ha! If you get funded by the Belmont Forum, you're going to love our template because we map every single section to their rubric and requirements, and we tell you which ones it complies with. You'll love that part. I'm going to skip some of this. All right. So what do you mean it's 20 pages? All right, Shelley, break it down for us. Make it easier. All right, you got it. And I did use the same cat as I used earlier this week. So if you're new to this workshop, we did see this cat previously. It's a favorite on the project. Okay, so we talked about making the decisions. You do need to get the PI involved because they are going to have to back this up. So you're going to want the PI to say, yes, this is my proposed DDOMP. Can you please take a look at it, make sure it's good? By the way, I need you to ensure that all the researchers comply. This is their job. They need to look at it and say, this makes sense. By the way, you've done such a good job. I shall give you more money. You are so valuable. I'm going to include you on all of my research going forward. Do you love this? Do you see how wonderful this is? Okay, I'm helping here. And this is a very small shelf right there. Just realizing. We think we talked about the rest of this, so I'm going to keep going. So here's your letter to the PI. Here's the talking points. I'm going to read it out loud because it requires animation. Dear PI, oh great one, your research has no bounds. This is a parody, by the way. Please accept these simple guidelines from your humble person, your humble postdoc, to help your team manage data and software as you explore your hypothesis. Also, please use your prominent position to ensure the team follows the checklist that you established. By the way, here it is. Please share with the team your true dedication to robust data and software management. making preservation and publication much simpler when the time comes. Remember to say publication several times with emphasis. Publication will be easier because you did this, sir, or madam, or other. Remember, your funder, journal, and your mother require you to cite your data. If you missed any other talks, it's really important for you to put citation on anything. And one of our posters actually several of our posters actually had citations of data. You're my winner, by the way. I don't know who's actually going to win, but for me, you were my winner. And also, data citation can lead to increase in citation of your paper. Fact, I have that. I have research I can give you, not mine, but others. It has been published, where if you cite your data, it actually increases the citations on your published paper. Oh my gosh, people, why are you not citing your data and your software? This is a no-brainer. Yes, I can give that to you. Yes, I can. Haven't I not given that? This is Cielo here. This is one of your publishers. Great. And this is a bonus for promotion and tenure time. Your DDOMP coach. Okay, there's your letter. Great, got it? Feeling confident? You can walk up to the PI and say, thou shalt. Good luck. So the benefits of putting this workbook together. So this is the 20-page document. You're able to be very iterative and flexible. You're very clear on exactly what needs to be managed, because you're going to have a bunch of researchers that say to you, well, does this apply? Does this apply? Does this apply? Think through all of that, because frankly, not everything applies. If they're noodling around on an idea that they're likely going to get rid of 24 hours later, no, not really. You can just noodle around and everything's fine and the world doesn't fall apart. But if they're working on a data set over time and you want to make sure that like the whole laptop being taken issue doesn't happen to them, then you need to get them to make sure that things are getting backed up and being well documented, et cetera. Okay. And during the project and preservation following the project. The key for preservation following the project is two things. One is evaluating your research. When you submit for a peer-reviewed publication, the reviewers, to fully evaluate your research, will likely need to see your data and software in order to demonstrate that what you did makes sense, right? That they're going to evaluate it. So that's one. And then transparency, to make sure that we're open about our research, that there's not anything hidden or not understandable. And the third is actually the whole purpose of science is to build on work prior. And one of the things that's really important there is, imagine if it's really easy for you to see all of the research that's happened around the world, no matter what language, and you can actually design your research to build upon that. And right now that's really hard to do. So there's a lot of potentially repetitive work happening just because you weren't aware. So wouldn't it be cool if we all could build upon everybody else's work and move forward to solving all kinds of cancer issues, or pick your favorite societal challenge. All right. So we're going to walk through the validation checklist in a moment. So let's get to that one-page checklist. Great, Shelley. All right. There we are. Okay. Here it is. That's it. It's really not a big deal. So I have on the higher level item where it says material development, temporary storage. In the color, I don't know if you can tell, it's like a purple color. Those are the answers for our team. So where are you going to work from? Where are you going to keep stuff? Well, we're an international team. It's really easy for us to use Google Drive and all the Google products. So guess what? We're doing it there. What's really important to know is that you want to back that drive up. So there's actually a tool to back it up that you have to add in. So that's in the DDOMP. Ha-ha. How are you going to communicate with your team? Crazy moment. Imagine if you didn't have a list of email addresses, because if you have a large team, you may not know everybody's off the top of your head. Wouldn't it be great to just organize that through a Slack or through an email list? And our team actually works best on email. We do have a Slack channel, but it was not as popular as email. So we learned over time that email is the preference. So fun fact, we do have something to improve on our own team. Only the country leads and the PIs have access to the full team email list. So we should have made that open and did not. And we've run into some trouble. And it's actually to do. And silly me. So there you go. I'm giving you something that is so simple. But if you need to take the time to actually make sure that when communications go out, it goes out to everyone, and that you're not forgetting people, and you're making sure you're being inclusive of the entire team. Crazy, not everybody does that. So data set storage. We do have Open Science Framework, OSF, which is available internationally. It's really fantastic. It's very robust, and you can connect into your Google Drive, so your Google Drive can actually connect in. And we also have an AWS instance through the University of São Paulo. Cool, right? Our software development platform, GitHub. Who does not use GitHub? Okay, down. Everybody uses GitHub? Okay. Who uses GitHub? Oh, come on, hands, people. Okay, you know what it is. Super. All right, it's brilliant. It's absolutely brilliant, but it's not a preservation platform. It's a development platform. This is really important. So if you jump down to the software preservation repository is Zenodo. Fun fact, GitHub and Zenodo have a bridge. So when it's time for you to preserve a particular release or go for a publication, use the bridge because it creates the preserved version that you can then cite in your paper. So yay, go team. Way to use the most popular development platform. Woo! So for data preservation, we actually have a professional data curator on our team. Was that not the smartest thing for us to do? Margaret's right here. You're gonna hear from Margaret later. She's represented by the Environmental Data Initiative, and since our work is primarily environmental, yes, it's modeling, but it's also environmental, we love working with her. Now, they're one of the most established domain-specific repositories, and they take both data and software, but we've made the decision to put our software in Zenodo because that is the more, that's the preference within the community, that software lands in Zenodo, but EDI can also take software. And what their particular support, by having somebody on the team or having a relationship with EDI, you get all of the documentation necessary for data, the right formats, connected to community accepted vocabularies. This is so awesome. You want to pick the best possible repository because you actually get help to do your work. It's fantastic. And we have a lot of training material, so that all goes in Zenodo, and I already told you about our community in Zenodo, where you can find everything. So, for PIs, we did lose one country, by the way. They were unfunded, and they actually became the president of the European Geoscience Union, so she was a little busy. So we lost one country lead. So we're now down to 5. Don't worry, we're keeping all 5. So it's France, Japan, Brazil, the US, and Australia. 4 funders, so all but Australia are funders, and 40 researchers. Actually, I think we're up a little bit right now. And we have 4 separate languages. So we all came together, and we have a simple set of, this is it. This is all you're building. This is all you're building. And the 20 pages is making the best decision on which tools so that everyone on your team around the world has equitable access. So note that we did not pick an institutional repository. Not everybody will have access, right? So you have to think about these things. So tracking and reporting. So this is more the PI. But you know the PI will say to the postdoc, can you go make sure everybody's following these? And you're like, oh, good bloody luck. So let me walk you through. We actually have updated this particular slide. Actually, Janeth updated this slide. She made it really interesting, but Janeth, I didn't swap the slides out, so I'm sorry. She made a really gorgeous visual on this. So the very first item is, and we have an ORCID talk later today. Let's see. Some of you got homework assignments to get your ORCID put together. Who has their ORCID at least established initially? Okay, overachiever. Okay, I got 1, I got 2. Oh, yes. Okay, you need this. You need this right away. You can do it immediately. You can get your number. This is a persistent identifier for you, the researcher. You're going to need it to publish. You're going to need it for everything that you put onto any repository. You need to put it at the bottom of your letters to your mother. You are now connected. Yes, I mean that. You are connected. All of the digital objects that you create need to have this number so that the hub on ORCID has you connected. It's not a CV, it's a hub. You can also connect other identifiers from other organizations there, Scopus and Researcher ID and others. But this is the master hub. Why is ORCID the master hub? Because the publishers said ORCID is the one we're going to single up on. And frankly, just go with that. Because getting the publishers to change is nigh on impossible. So just get yourself an ORCID and get it updated. So there's also something else you need to do, and we have a publication on our Zenodo page called Digital Presence. So we talked a little bit about it yesterday, but take the digital presence, it's like a 10-minute video walking you through why your ORCID matters, and also how to create the automatic updates. Okay, we're gonna go in the weeds. Okay, strap in, you're gonna love this. More acronyms, just hang tight. So when you publish, who's published? Who knows someone who's published? Okay, come on, get your hands up. If you don't put your hands up, you're not a researcher. Put your hands up. Oh my God. Okay. If you're an English-speaking paper, and I'm looking at Solange because I think this is true. If you're an English-speaking paper, the paper will receive a persistent identifier from a registry agency called Crossref, C-R-O-S-S-R-E-F. You will likely never see that word ever again, but you need to know about it at least once. So when you publish in an English language, you're going to go to Crossref and you're going to get your persistent identifier for that paper. And when people cite your work, yes, which is what you want, that number is what will connect back to you for credit and attribution. So you math and computer geeks, this is linked data. Get me? Okay, there's not enough heads nodding. I got 1. Yes, you win. So when you want to link between you as a researcher, like think promotion and tenure. Okay, let's something that you want desperately. I want to be promoted. I want to be recognized for my amazing thinking. Me. Your ID on your paper, your data sets, your software. What I can do is I can go look there, and by the way, there's a tool I'm going to tell you about, and see all of your contributions. It's so easy. So the tenure committee, right? The tenure committee will pop your ORCID in and go see everything you've done. Everything. And you want that. Or your society, because I come from a society, I want to invite you to be on a particular working group, and I'm interested in somebody who knows artificial intelligence, machine learning, ethics, and I want an early career researcher, so if you don't have your ORCID updated, I can't find you. I won't know to find you. You have to give me the metadata about you so that I can find you. So this is a big, big deal. So what that link is up there is the automated updates from Crossref anytime there's a publication that comes in. And Jessie Jo, was it Jessie Jo? Who was it? Was it Jessie Jo? Jessie Jo she's one of our technicians on our project. She's just now graduating with her master's, and her very first publication just popped up automatically on her ORCID profile, and she was so excited she almost sent me the email to tell me. This is amazing. It means you don't have to type stuff in. You actually have somebody automatically updating the hub of your work, right? And you should link your CV in there, by the way, too, because it is true hub. The other registry agency is primarily for data sets. So when you publish a data set or publish software, that's registered through Data Cite. You also want to hook up your automatic updates from Data Cite as well. So that's what that link's going to show you how to do. By the way, the interface is so horrible. You're going to have an opinion on it. You're going to say, this is terrible. I could have written this better myself, right? Yeah, sure, but just do it anyway. You only have to do it once. Tell all your friends. This is literally something every researcher should do, and you only have to do it once. Make sure your friends do this. They're going to thank you later, because all of a sudden people know about you, and you're like, oh yeah, I put that automatic thing on my ORCID like that lady in pink said. Yeah, tell everyone. If you belong to a fraternity, tell your entire fraternity, assuming they care about research. Okay, so that was just number one. That was my promo for number one. Oh, we have questions? Okay, good. Okay, all right, cool. Great. So then you're in your research, right? So track the data sets that you're using, create a tracking list. Actually, Professor Pedro has a team that's actually working on a database an entire software tool that does this. We're really excited to test it out pretty soon. But meanwhile, you can just use a spreadsheet. So use something. Don't like, oh, I'm going to remember where I got that, where it was, what the exact URL was, the day I got it, 5 years from now. No, you're not. Literally not. I can't remember what I did last week. You probably can't remember what you did last month because we're different ages. Okay, just write it down. And then monthly, think through what you have to prepare for the next part of your research. Are you about to go to a conference? Are you going to do a poster? Whatever's supporting that poster should be preserved. Get ready to put that poster into a repository so you can have a citation. We don't know, don't tell me that there's no place to put it. There's gobs of places to put it. There's a archive, preprint archive that takes posters that the folks that did a poster session yesterday have access to. There's also Zenodo that you can put in, any generalist repository, but make sure it's going to give you credit. Make sure you get a DOI for it so it can cite. DOI, Digital Object Identifier, for a digital object. Okay, and then quarterly, make sure that ORCID's being updated. Make sure that your best self is being represented to anyone who might be interested in hiring you, having you work on boards for societies, having you participate in international meetings, wink, wink, get your ORCID updated. Oh, and fun fact, all right, you all have a Sao Paulo email, right? Yes, of course. So in your ORCID, also have a personal email that stays with you always. So when it comes time to graduate and your email, the University of Sao Paulo, is ended, that you can still get to your ORCID profile afterwards because you have a backup email. Think ahead, okay? So do both. You don't have to make your personal email public. You just need it on the account, okay? Good, right. I got you. I have your back. Trust but verify. So this is a new process for an entire research team. They're not going to do it. You're going to need to nudge them, and you're going to need to hold their hand, and you're going to need to help them. That is a fact. Until they've done it once, until they've done it twice, and we have documented evidence, is Katya here? Documented evidence that it doesn't take too many nudges before they go, oh my gosh, this is super helpful. Why haven't I done this my entire life? So it will pay off. You just have to nudge them along. So is anybody here a PI? Don't put your hand up. Is anybody here a PI? Mostly not? Okay. Oh, yeah, okay. That's how I know about you. All right. So mostly you're not going to be the PI at the beginning. Eventually you will be. But I'm giving you slides on this presentation because a lot of the convincing to make this work is because you need to have the person saying, yes, this matters, listen to the postdoc. Like, you literally have to have that in place. So I'm giving you a whole bunch of helpful slides, which I'm not going to necessarily go through here, to help you talk to your PI. So we did a poster presentation. This was a lot of fun. You have to do that whole, and I'm using a sheepdog here, meaning keep everybody together. You need the high-level nudging in order to make sure researchers who have done something for 30 years comply with something new. It's necessary. So here's the details. I won't go into it. I don't have a clock up here, but I'm pretty sure I've run over. Okay, yeah, all right. There we go, okay. And there's backup slides that actually tell you what exactly is data and software management so that when you talk to the PI, you can be specific and reference these dots. More into the data stewardship and why the data management plan is important. And no, you can't read this, but when you get the slides, it'll be useful. And what software stewardship is all, by the way, it's different. That's why there's two fuzzy animals that give wool, but they're completely different. Got that? Isn't that funny? Sheep and an alpaca. They're the same, but they're not. That's a joke. That's a real joke. Right, okay. That's it. So those are for your backup slides.
Thanks very much, Shelley. Do you have any quick questions? You're very welcome. Yes.
Yes. Shelley, thank you for the presentation. From me, from the YouTube guys here who are watching you, AKA the lady in pink. So the question for you is the following. What do you recommend for keeping big data safe in a globally distributed team? This was asked by Marco Souza.
Big data. Okay, so let's go with many terabytes for defining big. That's actually hard. So big data either coming, so if it's big data coming from satellites, INPE or NASA or NOAA, the organizations that have the satellites, primarily they should have the means for that. They would provide the means for that. What I'm thinking for someone who's in this room or online is you're running a model that's pulling in large data like that, and you're generating model runs that create terabytes on the other side, for example. Well, it actually is quite hard. If you go to data.agu.org, in the blog post, there's a description of what to do with large data. Because the community has not yet come together and the funders have not yet funded how to preserve very large data. So there is workarounds. Now, that being said, Globus, which is an organization that moves large data, also has a repository. So GLOBUS, Globus, check that out. Many, let's go with many, more vague. Many institutions have a relationship with Globus because of how valuable that service is, that technical service. And I just heard about it. That's a new thing, that they set that up. Additionally, Figshare, who's a generalist repository, provides preservation services, but it's for money. Most of their smaller data sets are free, but very, very large data sets are costly. Additionally, for us as a journal, if you go to data.agu.org and look under resources and look for our author guidelines, we actually explain that for a modeling situation, it's not the data we're most interested in, because that's not observational data, it's simulation data, and we are more interested in your model. So you can argue, no, my data is amazing. Yes, it is. However, we literally can't ask you to preserve something that is not possible to preserve. So we come at it with consultation with the researchers. Well, if we can't have the many terabytes, what should we have? And the answer is, well, at least the model and maybe certain runs of your model. So it's not all of it, but some of it. Hopefully that helps.
Thank you. We have another one. Do we have time? Okay, thank you. So this is from Artur Artoni. He's asking if you have any tips for getting access to medical-related data sets.
Oh, actually, Laurence is your expert there. So these are medical or health or personally identifiable information protected data sets. So this aligns to the work in PARSEC where we're asking for socioeconomic data. You have to, it actually is many more hoops. And It is actually quite difficult. Lawrence, I think you actually have to answer this one for me because you're the one who navigated it for us. But the PI had to be the one who reached out to get access. And then because of the requirements, the data agreements, we cannot make that data open. You have to comply with law and regulation. So even though we talk about open data, there are reasons why you wouldn't make it openly available, and which makes sense, right? One of the challenges we had is we were looking for census data, very protected, address by address, and we could get access to aggregated data openly, but not individual data, the individual detailed data. But what we did learn is through relationships with the repositories that have that data, you can partner with them and get access. But I'm not the expert on that, so I would say that we would want to pull in some additional resources for anyone who has a specific question, because it might. Okay. Yes. Okay. Okay, good. Thank you.
Okay, so I have a data question. And so just as a bit of a backstory, so I did my PhD in biochemistry, and we used to always laugh in my lab about how we needed a journal of negative results because we did so many research experiments that failed, but we probably figured after we had all of those failures that someone else is probably doing the exact same thing in another lab but has no idea that we failed this many times because you don't publish
You don't
negative
publish
results.
on negative data.
So you say
right.
data repository, and I think to myself, wouldn't it be cool if I was able to publish all of those negative results in a data repository? Does that happen? Is that possible?
It's incredibly
Would that
uncommon.
be cool?
Yeah, it would be cool. So imagine a world where our careers were not fully based on positive results, right? Okay, so all of you have just checked out. Oh, no, that's not me. But imagine if you had access to the negative results from all of your coworkers, from all of the folks in your discipline, and you knew that under certain conditions that these things happened and this did not work out. Would that not shape how you chose to move forward with your research? Maybe you would want to try a different approach to the same method, an adjusted approach to the same or similar method. That does make sense, doesn't it? But you're not rewarded, incentivized in any way, shape, or form to publish negative results. So I do know in the medical field, the Center for Open Science, who hosts the Open Science Framework, has a mechanism in place where you register the research you're going to conduct, and then there's an agreement from a journal that they'll publish it no matter what your results are. And this is starting to take hold as a really neat way to capture negative results. There's not a full uptake on it yet, but it is leading the way on making sure negative results get published. In the earth and space sciences, we don't even think this way. That's not even a thing for us. So that it is a very hard cultural thing to do. But it makes sense that we should have a space for it, a way for people to get open access to negative results, and would be an opportunity for some scrappy postdoc to say, oh my gosh, this would make a whole lot of sense. I think I'll start a consortium to move forward with this in your future. You can keep that in mind, or perhaps a funder will encourage that.
Because I could imagine a state where you don't have that publication, but your data is cited because someone else says, oh my God, they already did this. So I'm going to say in my paper, this is why I didn't do this. Because someone else already did it this many times, and here is that data. And then you get that citation based on the negative results, whereas you weren't able to actually publish a paper, but the negative results did get you some positive feedback.
I love that. I truly love that. And that makes sense to me. But we don't, would your tenure committee give you credit for a negative results paper? No.
But maybe if there's numbers.
It
Let's say
depends.
that the data has been used.
So, okay, tenure people out there, think about that. Wouldn't that be a contribution to the scientific record that is maybe not equally valuable to positive results, but yet incredibly useful for the next research? I'm looking into the camera. I'm sending that vibe out worldwide. somebody's going to clip this part and hopefully send it to many people. Who knows? Maybe that'll happen. Thank you.
Thank you, Shelley. So by the way, I'm Laurence. I'm part of the Data Strand of PARSEC. I'm happy to be the moderator today. A little bit late, sorry, but we had a taxi issue. So I think we need to move forward. So the next speaker, the next presentation is a recorded one. So I think it's gonna come. And it is from Romeu David. Romeu is a research fellow and data manager at the European Research Infrastructure on Highly Pathogenic Agents, so European, yeah. He's also part of the European Science Open Cloud. He's a member of the PARSEC Data Strand, and he's got 15 years of experience in terrestrial and marine ecological engineering and database management, network animation. He's a data mining and graph approach addict and a data management plan with fair compliance evangelizer. That's his words. In addition, he's passionate about effective and powerful communication, both human and machine readable, data vocabularies, in particular multilingual vocabulary solution. And he's also a co-chair in RDA Research Data Alliance group on credit and rewards. So, Romeu, the floor is yours as a recorded presentation. So, and the talk is
Hello everybody, my name is Romeu David, and I will try to present to you for this training session in Sao Paulo, but remotely because I'm in Brussels. Processes and pathway to disseminate science for wide and efficient reuse. First, you know what the PARSEC project is and sponsored by the Berlin Forum. But I have to say, as all the other presenters, that we acknowledge the traditional owners and custodians of the land and sea, all nations. We honor their profound connection to land, water, biodiversity, and culture, and pay your respect to their elder past, present, and emerging. Where I am working, I'm from ERINA, that is a European research infrastructure on highly pathogenic agents. It's a research infrastructure that work on high-risk microbes or highly pathogenic agents on BSL-4 laboratories that are laboratories that work on disease that you can't create. So diseases like Ebola, Nipah, Marburg, Crimean Congo, hemorrhagic fever, but we work also in our network with BSL-3 laboratories that deal with COVID-19, for instance. And we have lots of issues and problematic like maintaining containment and have personnel and information security and at a national and international regulated level. So my role is to define and implement ERINA data strategy. I'm the data steward and scientist at ERINA, and I work for ESCLA European program. And we have to verify data and to communicate on all the tools that we develop. I have to manage all data-related activities, and I'm the representative for ERINA in collaborative European project, not only on ESCLA, but also in ERINA Advanced by COVID Isidore, that are linked to the pandemic preparedness, and we have to disseminate outputs, and it's the reason why I've tried to do this presentation today. So the ESCLA program, only few words about it. It's 13 research infrastructure that are mainly in life science, but it could be vaccine, health, image, human health, or clinical trial, or it could be animal experimentation, could be plant phenotyping, and marine models, organisms, lots of things like that. And we are trying to establish fair life science data resource. And for that, we provide policies, guidelines, and processes for secure and ethical data reuse. And the reuse need to communicate. And we want to populate an ecosystem of innovative life science tools and enable data-driven research in Europe by connecting life science to EARTH via open calls for participation. And open calls need to have participants and need to communicate a lot with lots of platforms and lots of tools. So it's what I want to present to you today with several tools. But first, why disseminate science and how? I will present that in the first part. In the second part, the tools and processes that are needed to do that properly. And it's example of tools, but you will have others in other practice, but it's good to have in mind that you can use that in this way or in another way. And I will try to summarize some good practice and lessons to be learned that were the good, the bad, and the ugly in my career. So why publish your scientific outputs? So first is, yes, it's to be read and to participate in the debate, but more it's to debate, to propose your theories, to exchange on them, and to be reused in the future by other scientific approach. And in your career, it's to build collaboration. So yes, it's to be known. It's something to advance yourself, but it's to advance the community around you and to build a common future in the same time. So when you are thinking about your dissemination plan, you have the real world objects like a paper, journal that are the main output of scientific peoples, but you have also books and posters, and sometimes posters can have a real impact, and you must not neglect them. You have seminars and talks that are really useful and common, but only talking with colleagues and have meetings, it's something really powerful, and we do that continuously. And in the digital world, we have this kind of objects. We can have remote seminar and talks that change and permit to have more of them. And we can provide emails and also exchange with colleagues with other tools like websites that are adapted for project sharing and project inside the project with the team, but outside of the project with other project too, using personal pages, using a project interface, using e-box. There are lots of interfaces that permit to exchange with communities. And in these tools, there are social medias in research fields and internet dissemination tools that could be platforms with all your references and all the relays that they provide in several communities automatically. So first, you will use internet. Internet is the first internet server was in the CERN in Geneva, and it was supported by American, Japanese, and European, and it was a way to communicate between several teams in the CERN, between 2 or 3 labs at the beginning with appropriate protocols to communicate text only on the experiment and on the science that they provide. At the beginning, it was only a network of 10 or 20 machine, and it was incredibly increased during following years, as you can see. So now we have communities. For instance, I'm co-chairing 3 groups in this community. It's a Research Data Alliance. As your purpose is data science and machine learning, I think that you will find in this fora lots of possible collaborations. This Research Data Alliance is a global organization with over than 12,000 members from 145 countries. The principle of the Research Data Alliance is our openness, inclusivity, and transparency. So it's free to be in a group and to participate. And after 1 year experience, you can co-share activities in this forum. There are lots of other in other communities, but in data science, I encourage you to be involved in this kind of platform on community. So to communicate, the first key component is metadata. If you are in your kitchen and you want to eat something or to drink something, if you only have contents that don't have metadata, you will not know where it's come from, and you will have no idea of if it's meat or vegetable, and if you are allergic for some things. So metadata are really important to give the entry to your output of research. For numerical content, you have to consider the efforts, the relative efforts that is to be done for your work to describe it, the technical development on websites and interfaces, really short time, considering the times that you have take to produce the content. But the communication task, it's a long-term task that can be provided several years after the publication. So you must consider that it's important to valorize the effort and the money that you spent. And for the format of what you publish, the summary, half page, it's on internet, it's 95% of the content that is written. So that means that you must privilege several summaries for the same output, research output, or the same research project. And after, you will describe it in a longer way, but the entire work will only be written by just a few parts of the people that have that know that the work exists finally. So what are the tools and processes that you can use? First, I recommend Zenodo. Zenodo have several advantage. It's in the same way that the Research Data Alliance open, it's free, and it's supported by OpenAir and the CERN. I told about the CERN from Genève as the start of the internet. So they are supporting this project, and this project can permit to describe all the metadata for your research output, and to create communities and collections that you could provide and link your project and your outputs two founders. And it permits to describe and to identify all your components of your project and your outputs with DOI that are based on a versioning system. So each new version of your output will have a DOI. That is not the case in lots of DOI systems. And the second thing is that you have a main DOI for your last research, and you have a DOI for each version, so you can designate only the entire work. So the last version will always be the pointed version, and you can have versions very discriminant for part of your work if you think that this version is relevant for the building process. So I use a lot Twitter too. So Twitter is a media that needs very short message. You have hashtag to, it's like keywords that you add, and you have a way to tag people's or infrastructure or communities that have an account to say, oh, this could interest you, or in this you have participated. So you can talk about the conferences. You can see in Twitter lots of papers that are coming out, or that are all conferences that are taking place around the world on a subject just by following the right communities. When you are following the community, you know that other people do the same. So when you publish something in a community, there are always bigger impacts. So it's not to be neglected, and a lot of people that are well known have more than 10,000 followers. So in one click, you can reach lots of impact. Other interface, private interface exists, like LinkedIn. This one permits to detail more your CV and to propose longer articles on the statement of your research or your activities or a conference. You can add image, and you can recommend the works from others. That's the case, the recommendation on that's the case on ResearchGate. That is another website that propose to build communities too, and to link your outputs to several projects. So you have means to follow your impact with the number of views, the number of citations, the number of downloads, the number of recommendations. You have saving system to keep in mind some works that you are interested in, and you can request private texts that are not available publicly. So from my side, I use it for community building and to see the scoring, but it provides a DOI system, but it's not recommended because as it is a private company, the DOI could be raised. You have other identifiers than DOI, like National Archive, for instance. This one is HAL, that is the French one, but you have this kind of archive in your country. And in this kind of website, you can have a permanent CV because you will change your affiliation and your infrastructure during your research life. So it's important to have something common and to have something stable in time. As you can see, you can list all the research projects where you are. You can have a summary of all the keywords that you use to describe your publication. and all the funding that you have, and you have a link to all social medias that you use. So it's a good overview of what you do on internet to be well known. And you have a way to export your CV on your publication with all metadata in lots of formats like XML, with text, etc., CSV, XML. The last thing that is really important is that all your content, all person, all infrastructure will be designated by identifiers. And in this page, I have all my identifiers, Google Scholar, ORCID, Research ID, IDEAL, etc. So the other good point of these national archives is that they are more and more linked to the global ORCID system that was already presented to you during the training session. So you can see that it is synchronized with PubMed, OpenAir, Scopus, Elsevier, and others in your country. We'll let you check that because you had. So the better thing to do is to communicate by email about your outputs with your mail or with mailing lists. And in the mail, you can put a Zenodo link. And in the Zenodo webpage, you will have all your affiliations, all your projects that are linked to all collections of each labs, and all these collections and all these networks are windows to your research. So if you demultiply the number of windows that you have in your system, you will demultiply your impact. So after, yes, you have technically the platforms, the tools that you use, but the most important is the content, because it's the way to be known, to be impactful. So always brainstorming is the base. For this presentation, I had my little brainstorming. I hope that it's pleasant for you. And you have to apply fair principles as possible as it is on each of your research output as digital object. Because if you have all fair components like identifier, like rich metadata, like provenance component, how does it, it will be made and built during time, what are the protocols that were used, what are the parameters for software and things like that. What is the license? How can I use it? And what are the community standards that you use? All these kind of aspects are presented here in our paper on the well of the verification processes and are applicable to your research in a community context. And if you want to have more impact, always build your communication strategy in a community context. So after you have other ways to see what is the impact finally and during time of all your research. One very well known but there are lots of others, is Google Scholar that permit to see all the citations that you have in all indexed journals. There are lots of other interfaces that do that, but for this one, it's free. And you have to manage the content of this page to arise when you have other authors that you have the same name than you. So that shows that it's really important to have an ORCID number, because with an ORCID number or unique identifier for person, you will not be the same than another researcher. To assess impact, I use Altmetric. Altmetric is a way to have an overview in lots of different kind of internet way, like news, blogs, Twitter, and you can have patents if you have chance to have it. I have put here the example of the FAIR Guiding Principles paper published by Wilkinson. So you see more than 2,000 citations, and it will increase during next year because it's only 4 years after the publication that we have this number of citations. And you can have here the detail of all the media that are taken in account. So you have Facebook pages, Wikipedia pages, Google Plus is not existing already, but you have Redditor and videos uploads on YouTube channels, for instance. And you have the geographic source of the people that are talking about your output, your search output. So it's a good way to try to increase it in several community or in several region to be more impactful too. So after the collaborative work is a way to have a good start because you have more people that are implied, and they will, during the time, if they all have the same approach of scientific communication, it will demultiply your effect at the end. So data papers, data sprint with a lot of people for a research report and radical collaborations are really important to provide more effect. So now some good practice and lessons. First, be original. It was our last Data Strand poster. This one was really successful. In several months, we have several hundreds downloads and views. And I hope it's better to read something like that than something in one block without a picture. I think that more and more scientists have understood that they have to catch eyes. So, for instance, for the PARSEC Data Strand poster, we have a tweet can have more than 300 impressions. So you can tweet regularly when you reach a milestone to say, yes, this poster is related to this conference, go and see it when it's on Zenodo. The dissemination pathway, to summarize, for poster communication, paper submission or acceptance is the first step. So when you have your paper, your communication, your poster, you put it on Zenodo, and after you publish during the seminar, the congress, the meeting, tweets and message on the poster, tagging peoples in the poster, in the message. So people will recommend your publication or will retweet what you said to increase the impact. And larger your community is, and the community of your colleagues are, greater will be your impact. You can put it on other archive manually, automatically, and it will be used by syndication with international system like ORCID and PubMed and others. And do not forget websites of structured projects, series, and personal page. After, when you email, you tweet you use LinkedIn, you have to use tag for increase people participation, and screenshots to catch eyes, catching eyes and catching relays. And as I said at the precedent slide, at each occasion you can communicate. So we have in the PARSEC team 3 checklists that are on Zenodo with the link that is below. So do not hesitate to use it and to comment it. And if you have to adapt it, it's a CC BY license, like this slides. So when you indicate CC BY, that means that everybody can reuse it, and it's a way to disseminate, to be reused. So, as an example, for the fairness literacy, we have trends for the views, the downloads, the tweets, but we also have a relative importance in the publications, in the journal, in the all research outputs that are in the Admetric. So I have put here the references. You will not read it, but it will serve to research engine. So it's a good thing to have it in the slides, and you have all the DOI links to Zenodo on other platforms. And research engine will take it as a piece of good food to increase your visibility. Thanks for your attention. So have fun, catch eyes, take care of your take-home message, and do not forget, first, content, 2, lots of links, 3, based on community, 4, daily communication, and 5, access to increase your communication when it's lacking. Thanks to the PARSEC Data Strand and Alison that have a quick review of my presentation, but it was really useful. And I hope that you will have fun time. And thank you for your attention. Goodbye, everybody.
Thank you to Romeu and David. We're a little bit late, so I suggest that you address your questions directly in the chat for the remote participants, or you can come to us and we'll find a way to do the responses. So we move forward with Margaret O'Brien. Thank you, Margaret. So Margaret, let me introduce you. Sorry.
Thank you.
If I found, I'm a little bit lost in my notes. Alison gave me so many.
So much paper.
Yeah, can you find, where are you?
Where am I? You know what, I'll just wing it. There I am.
Yes, sorry, I'm sorry. I need my glasses.
I'm somewhere.
So Margaret is a specialist in data management, data manager at University of California. She's, of course, is a member of PARSEC Data Strand. She's a data manager working with networks of ecosystem-level research, including the US Long-Term Ecological Research Network, LTER, and the US Marine Biodiversity Observation Network. She's currently key data manager for the Environment Data Initiative, and she's the selected repository for the PARSEC project. So this is all yours.
Thank you. Thank you, Laurence. Is this, and how many people do we have online? Just curious. Okay. I have so you're probably wondering why you've heard a lot about archiving data, a lot about why you should, and I'm going to give you kind of an overview of what it looks like to archive data and how repositories operate. I call myself a data manager or a data curator, which is kind of a cross between a research librarian and a software developer but we're not expert at either one. But we're pretty good at communicating between the two, going from talking to researchers and scientists in a particular field and also understanding how software development works, because digital repositories are basically software. So my own scientific domain, my training is in biological oceanography, but now I work with larger ecosystem scale investigations like the Long-Term Ecological Research Network, and particularly with biodiversity and ecology. So that's my background. And oh, clicker. I got it. I'm going to, okay, so why are you being told to archive data? This is why. Over time, on the x-axis, the details about your data are going to degrade. It just happens. So basically, when you create that data, you know everything there is to know about it. The posters we saw outside, you knew every detail of that poster. Everything that went into it, you could explain, probably more than your audience needed to hear, but you knew it all. But it won't be very long after you publish that paper that you're going to start to forget some of the specific details. They're going to disappear quite quickly. And then later on, even the more general details, like, oh, what was the name of that model that we used back then? Those are going to go too. At some point, you might have some technological disaster. That's when your hard drive breaks or your laptop is stolen, and the black line, it's all gone completely right then. You're finished. That data's finished. And eventually, you'll make a career change or retire, and then things really start to drop off, because eventually, whoever created that data set is going to die, and that's when the rest of the information just disappears. So, where am I? This is an example of a tropical bird study from 1980. It's a basic baseline ecological information that's still being used today. The paper is still cited, and it's also educational material. But this is what where the data are kept. They're still on tape and paper, and maybe those are cards and boxes, I'm not exactly sure. So that researcher is, do I have a pointer here? Is that little red line. He's about to retire. So I don't know if we can actually rescue some of this data because we don't have the equipment to read those tapes anymore. So what kind of data are these? You as data as modelers, you are using some of this, what we call long tail environmental data, as your ground truth. So this plot here on the right, I don't know if this is oh, it is. So what this is a plot of, this is from the National Science Foundation in the US. This is the number of awards versus the size. So what this tells you is that most awards are very small. It goes way out here into somewhere around, well, I think NSF awards something like 12,000 grants a year. So thousands of grants are very small and less than $100,000. So that means that there's many different collection methods, highly variable structure to these data sets. The semantics of what was done during that study is also variable. Some of them are long-term collections, which, if we're talking about environmental data, are not just important, they're irreplaceable. You cannot go back 40 years and collect that data again. If you don't preserve it now, it'll be gone. And why does this matter to you as modelers? This is a picture I took yesterday during the talks. I hope I got the citation correct, but the poster was gone when I ran back outside. So basically, this is the input data. Some of the input data for your model is this ground truth data that's collected by environmental scientists on the ground. But luckily, we're having sort of a culture shift. And now we look at a research life cycle that includes a couple of extra steps. You start your data collection up here, however you get your data. You go out and count birds or trees, or you go mine data at NASA or someplace from some satellite. You organize and understand it, and then you clean it up. This process can actually be quite long. And you write some results, you publish a paper. you create some data products at approximately the same time, but you're describing this data that you organized and put together for research, and then you put that data in a repository where now it's available for some use that you might not know what it is yet. It's undetermined. If it's an ongoing, especially if it's a model or if it's an ongoing ecological collection, you actually might update this data set and start again. This whole cycle can start again because next year you'll go count more trees and add to that original data set that you had up here. And also, there are now ways of stratifying how usable your data might be. This is these links are all on the slides, and they have access to the slides, do they not? Yes? Okay, so this is this concept is 5-star data. Basically, data is more usable the further it goes up to the upper right on this plot. So over here, paper tapes, local hard drives, email exchange, sending data back and forth, that isn't even on the spectrum. And that's the way a lot of research is conducted today. If you can put it into a PDF or any kind of a document at all and put it online, then now you're a 1 or a 2-star. If you can get it into a curated and into a domain repository, you've hit this middle spot, which is a spot we really like. And then later on, these more complex types steps are where you're more likely to find what we call mission data. And so these are the data on the far left of that first plot where I showed you number of grants versus money. Missions have lots of money, so they can afford data managers, whereas the small research groups cannot. So what's the repository's role in all this? Well, basically, we're a way to connect individual researchers over here on the left to the rest of the world. So we can get your data out into a location where somebody else can find it and reuse it. And that's true whether you're counting trees or birds, or whether you're creating a model and you have output data that you want to share for some policy reason or for whatever reason. So now we kind of look at how the cycle of how a repository operates. At the top, first thing we have to see happen is data documentation. Then it gets published in the repository over here on the right. We back it up and store it and secure it. And then we have to create systems for search and exploration and also to provide downloads and reuse. And then again, if there's this whole system, if there's revisions to the data set, we have to be able to accommodate those as well. So what are the kind of services that are involved? Like I said, curation and archive. We create metadata for aggregation, which is I'll go into in a minute. We create linkages for publications that go with papers, and this is how data gets to places like Scholix for Data Cite. And other kinds of aggregation would be these large programs like Data One, which you'll hear a little bit more about later. And we also serve as a hub for a community of practice. So that would be data managers. So this is a group of data managers here. I have no idea why they're all squatting. I guess they couldn't fit in the picture. But anyway, they were a working group working on data exploration tools. So repositories have a fair amount of responsibility. And as part of this culture shift, a lot of sets of guidelines are evolving now for how to handle data and how repositories should operate. So you've heard about these FAIR principles for findable, accessible, interoperable, and reusable. That applies to the data itself. These underneath that are what we call CARE principles, and these are principles that span the entire research life cycle, but having to do with handling data from indigenous populations. And over on the right, you see what we call the trust set of principles. I think people really like principles that can form words. It seems to be a pattern here. And this is basically how repositories operate. And then there's even, it ran off the screen. There are even certification systems where your repository actually can be validated, essentially, by an external board. So now what I want to do is kind of take you through, I hope you can you read that? I'll read it to you. Yes? Okay. So what this is a spectrum of data repositories, and I was going to get to this eventually, I hope. So what we have on the x-axis are the metadata and formatting requirements for the data that the repository accepts. And then on the y-axis it's your ability to find and reuse it. And so this spectrum travels up. Down here in the lower left, we have generalist repositories. And then here, next up would be things that are domain specific. So they belong to a particular research field, and they're able to create citation metadata, both of these. A little further up, we have more scientific domain specific, but they collect science metadata, and that would be more metadata about the observations themselves. And then further up, we have these specialized formats and metadata repositories. And those have very specific requirements, but you also can run very specific queries on them. And here's some examples of repositories that you probably have seen, or at least mentioned in some of the talks already. Over here in the generalist area, we have things like Zenodo, Figshare, Dryad. Institutional repository like Unicamp also falls into that area because they're typically specific to that university, but they go across domains, so they don't have the ability usually to collect really specific metadata about an observation. Then we have things like, if you're working in hydrology, you might be aware of HydroShare, which is a US repository for hydrology data. Then in the middle are these domain-specific repositories that actually collect metadata about observations. EDI is the one I work with. I don't think I've said the name yet. It's the Environmental Data Initiative. We're funded by the National Science Foundation in the US. And I'll have a little more history about that in a moment. Pangea also is in this area. Pangea hosts about 2,000 data sets from the international LTER among thousands of other data sets. EDI hosts the data from the US LTER, and we have about 8,000 data sets, I believe, right now. Ordinal DAC is used often if you work with NASA and the Amazon, you've probably gotten data from the Ordinal DAC to do ground truth validation. Now further over here in the specialized repositories, you have things like CBER, which is where the biodiversity data, that's a node for biodiversity data in Brazil. There's many of these, hundreds of these that are in other countries as well, but they all feed into GBIF, which is a global biodiversity observation facility. And these have very specific formats about how you put your data together before you can deposit it. So you have to have a very specific reason for putting data there. The reason being is that you want to be able to take advantage of their tools for querying across multiple data sets and observations. NCBI is a database of genomics data, primarily. And then way out, that kind of went off the screen, we have things like Ameriflux, which is atmospheric towers. And not only are they specific formats, but I believe they only accept data from certain kinds of instruments. And the same with PhenoCam. PhenoCam is a phenology camera network. So this is the kind of a spectrum of repositories that you're going to be faced with, and you get to choose one of those, for where you're going to put your data. And we like to think that this middle area where you have really specific information about the data, about your scientific data, is the best place to go. Then I mentioned metadata aggregators earlier. There's a couple that I want to talk about. The one on the right is Data One, and this is also an NSF, or was an NSF-funded project. Excuse me. And Data One has 44 member nodes, so they pull in metadata from all of these nodes, and it gives you like a one-stop shop. Basically, you can go here. Kind of works like Amazon. They actually collate all this metadata and then send you back to the repository if you happen to have found a data set you're after. And I think there's, I can't read it from here, about 20,000 data sets from that area of that map, which is mostly Brazil. There's also, which I learned about on Monday, an aggregator in Brazil called Oasis BR, and they are aggregating about a dozen data sources among other kinds of digital objects. So one of the things that these aggregators can do is data assessment. They can look at the metadata and the data that are in their repositories, and they can compare them to a set of rules that are aligned with the FAIR principles. And I'm sorry, you can't see these. I can barely see them. This is actually a little circle, like 100% would be completely filled in. And so these are both about 75%. So both of these two data sets, one of these is from the ILTER, this one is the ILTER from Pangea, and this is one from the USLTER. And they're both meeting about 75% of the checks that this Data One system ran, to see if they adhere to the 4 FAIR principles. Now, the idea of checking adherence to FAIR principles is pretty new, and as a community, repositories are still working out the best way to do this. So these can kind of change over time, but the FAIR checks they're actually version 2. You would see at the top of this, and the links to these data sets are in the talk. You would see there's a version of what the checks are that are being run. So how do you find a repository? The best place to go is RE3 data. So this is a registry of research data set, of research repositories, excuse me. This is not an assessment of the repositories, it's simply a registry, so you can find out what is available. And so you go in here and you can search for environmental data and see. I'm not quite sure how many there are. Someone could run that check pretty quickly and see. But there are, I would say, probably hundreds, and EDI and Pangea will be among them. The best way to be involved is with a group like RDA, which was in Ramon's talk a few minutes ago. Basically, this is not just for data managers. There are what I would call data scientists, people who are primarily scientists but work heavily with data. There are working groups there as well. And a little bit of history about EDI. Basically, we're based on 40 years of experience with the Long-Term Ecological Research Network in the US. And when I mentioned that culture shift, the LTER started in about 1980, and I'd say that culture shift was in the early 90s, about the time that the internet was invented. And that's about when the LTER decided that data needed to be shared, and it needed to be shared publicly and in a way that people could actually access it across all these sites. And so in the early 2000s, the LTER started developing this repository infrastructure, and they became a Data One member node early on when that project was first initiated. We started minting DOIs for data sets around 2010. And then we became the EDI repository just in 2015. And that is because this whole system was so successful that the funding agency wanted to expand it to a broader audience. So now, in addition to LTER data, we have thousands of data sets from all over the world. We tend to be focused on things from the US and from the National Science Foundation, but we're not limited to those. So please visit this link, and there's ways. I didn't go into any of the details about how this repository operates. I can talk to you about that individually or do a demo or something later on. So what do I want you to take home? So if you're a data creator, you just remember something bad's going to happen. You just don't know when, but your software is going to become out of date. You won't be able to read that binary file. Your drive is going to fail, or you're just going to forget. You won't remember. So deposit your data in a reliable repository as soon as you can, and certainly when you put that paper together, because after that you won't remember. And then in papers, cite the data you use. If you're a data user, the take-home messages are, oh, you know what, I'll cover some of this in my second, whoops. So sorry. I'm going to cover some of this in my second talk. There's a lot of research-grade data available, but it's not always easy to use or find. But any future use of data depends on good metadata at the source. It's very difficult to add. If it was hard for you to remember what you did a year ago, think about me as a curator trying to figure out what it was you did when I see a text table with a header line that's cryptic and nothing else. So I really can't add that metadata. I have to get it from you. So I'm going to skip this about linked data for now. Research data that actually could be more easily incorporated into systems like predictive models or synthesis. But what we need is, in order to do that, is we need well-described use cases from you as modelers so that we know how to prioritize what happens to that data and how to best prioritize how to describe it. And then we also need to have those kinds of use cases followed up with funding, because all of that takes time. And I think I broke it. Oh, I did. The battery came out. And those are some of the references. There's also references in the slides themselves. And that's it. And I think I'm going to give this back to you.
Yes, for the moment. Thank you very much, Margaret. Yes. Are there any questions? A few minutes for questions, for sure. Yes?
Hi, Margaret. Thank you for your presentation. I really like the FAIR principles. I think they really help to make your data more available. I have some questions for the future. Do you believe that maybe in future we can have some kind of, I don't know, FAIR principles checklist where a magazine or a conference may available, oh, your data check all the FAIR principles, so you may publish in this event or something like this? Because right now I see the FAIR principles more like a way to publish my data, but not something really formal in a sense of a checklist or something like this.
Can I use oh, thank you. The short answer is yes. The long answer is it's complicated. Because like any policy, they're kind of high level, and then it's left to the people on the ground to figure out how to implement it. And so the repositories and we're in a position where we can see a lot of data sets, and we can see a lot of what people are doing, how they're putting data sets together, how they define a measurement. And so we actually do have the capacity to go in and this is one of the things I didn't go into. Because of the metadata schema we have, we can read a metadata record and then actually access the data object, much the same way that when you read in a netCDF file, you know all about the columns and the grids and everything in there. We can do the same thing with CSV tables. So we can look at, say, the typing of a column and say, they said it was a number, but these are strings. So we can check those kinds of things. But which ones, where it gets complicated is that those checks are very granular and very specific to actual data values. And so coming up with the yes-no questions that you need to be able to feed to a computer, translating something like the letter I, interoperable, what does that actually mean in terms of the kinds of things you have to look for in a column of data? That's where it gets complicated. But that's what that one slide I showed you with the assessments from Data 1. They're working on it. My own repository has a checking system where every data set's checked before it goes in for certain features. And if the bar is fairly low, we really don't reject anything unless it's completely unusable. For instance, the URL that you gave me to your data table is broken. I absolutely, that would be a deal breaker. But most things, if we decide if it's human readable, that's okay. Because there's so much variation in the data sets that are coming in, we can't put really stringent requirements on things yet. But we can use these checking systems to nudge the community forward in a way that makes the data closer to reusable. Does that help?
No, I agree with you. Since we have a lot of different domains, and each domain has his own data, right? So each domain may have a different restraint. So it's a really big challenge to patronize all this content. Okay, thank you, Margaret.
Are there any questions? Other questions? No? I think it's time for a little break. I can see your brain needs fuel. So let's come back at 11. I think it's about a little bit more than a 15-minute break. And Margaret will give her second talk a little bit later in the morning, after the break. Maybe not right after.
Yeah, you get me again, I think, after the break.
Hello, people in the box. Is Ana Heredia online? Can I talk to her? Ana, are you there? Bom dia, Ana. Bom dia.
Anna and Leslie are online.
They're both on? Anna
Yeah.
and Leslie are on.
Yeah.
Bom dia, Ana. Bom dia, Leslie.
They are hearing you.
They are? I'm not hearing
Yep.
them. Oh, there we are.
I can hear you, and I've got the
Leslie!
alarm set in case I doze off.
Oh, Leslie, thank you so much for being up in the middle of the night. We have moved.
Yeah, I did.
Can you please
The-
turn
the
on your
timing-
camera, Leslie?
Okay. The timing wasn't right, Shelley.
I'm sorry, Leslie.
It just wasn't working. Then I suddenly realised it was daylight saving.
Ah, boogers. Buggers.
Hi. My screen sharing worked the other night, but if you'd like me to, I'll test it.
If you want to test it, you're welcome to. And Anna, you're also welcome to test if you want to as well. Anna goes in front of, goes before Leslie. Hello, I see you now. Hello.
You're going to have to enable us to share our screens.
Yep, you want to go ahead and try it?
Well, it's got host disabled participant from sharing screens.
Can you enable Leslie, please? Yes, it is happening. It is happening.
Well, it still says it's host disabled.
Hang on.
You're
It's getting
sharing my
fixed.
video, but not my
Eh.
screen. It says host disabled sharing.
I see a furious head working. Just one moment, Leslie. I'm sure we'll have it resolved in a second. So we've talked a little bit about RDA, but we've not talked about ESIP at all. So, and these.
Yeah, how much do you want me to put in on ESIP? Because I've just said, like, they've got clusters and community groups.
I can't imagine you consuming 45 minutes, right?
Yeah.
And they come from like physics and modeling, and so it's not
Yeah.
it's not straight up Earth and space or environmental. Yeah.
Well,
So yeah,
I threw geo and co-data in as well.
nice. Okay, that'll be good.
You can share your screen now,
Oh,
Leslie.
Anna, I see you now. Hello. Oh, very good.
Hi,
Bom dia.
bom dia. Are you in Brazil, Shelley?
I am.
Oh, this is great.
All right, that looks really
It's
good,
working.
Leslie.
And I put World Fair in as well. Okay, all right. Anna can
All right.
test now. I'll
Anna, do you have
stop
slides
sharing.
as well?
Yes.
Okay, and I'll send you both a link to the folder where you can drop your slides for later, or unless you already have it there.
I already have mine there,
Okay, great, thank you.
and I just changed the cover.
Okay, great.
Can you see it
Yeah,
now?
can you
Well,
put it into presentation
Yes.
mode? Oh, lovely. Okay, here it comes.
So, slowly
Solange says hello, Anna.
Sorry?
Hello, Ana. Solange speaking.
Oi, Solange!
Que bom te ver.
You make me regret not being there.
Ah,
You should. I'm just saying. You should regret.
Oh God! I just came back from a trip, so it was not possible from my personal perspective. I'm so sorry.
Don't worry.
glad
We're
to be
just
here.
teasing you.
my hug. You lose my hug. My warming hug you lose.
We'll have yes. Oh, that's so nice. All right, ladies, that's in good shape. Gosh, I don't know what time it is. How many more minutes do we have?
7, 4, 6.
6 minutes?
Yes.
Okay. Okay.
I
great.
can see you now. You're in pink.
Yes. Yes.
Lovely.
And for me to see you, I have to turn my back to you. I'm so sorry.
No problem.
All right. I am going to turn this mic off and then start to navigate everybody back in the room. So
Okay.
stand by. We'll come back.
Okay.
So for the folks up in the booth, we're going to start with Anna's presentation. If you could bring that presentation up, please. Hello. I don't remember the fellow in the booth. Oh, they're going to get someone. Hold on. What is? Raphael? 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 Raphael, could you please cue Anna? We're going to do Anna, then Leslie, and we'll move Margaret later in the day. Thank you. Shall I say it again? Or did you get? Yeah, okay. Very good, thank you. Just one moment, Anna. So I'm going to introduce Anna as they're getting Anna's slides queued up because we are super tight this afternoon. Anna Heredia, oh, there you are, lovely. Anna Heredia, who hails from the Sao Paulo area, is an international consultant with 30 years experience in research ecosystem. Her research comes from eco-ethology for 15 years, and she moved into scholarly communication and is a research information specialist. She recently has moved from her work with ORCID. So all of the homework assignments we've been giving you to start your ORCID, Anna's actually going to walk you through how to do that. So Anna, we still have music playing if you don't mind turning that off. Thank you so much. Anna, do you want to take it away?
Hi, hello. Thank you, Shelley. I regret not being with you today. I am in Rio. It's not that far, but I couldn't make it. So I hope that my presentation, my remote presentation, will be enough for you to understand the importance of persistent identifiers, the importance of data and metadata. So as Shelley said, I was engaged at ORCID in 2017 as the regional director for engagement in Latin America. And since 2021, I've been working as an independent consultant, but I still have very good relationships at ORCID. And so they share with me recent information, recent presentation, which I am sharing with you today. Can you hear me okay and see me fine? And the presentation, everything's fine? Yes, I guess. Okay, let's go. So, as I previously said, I would like to talk to you a little bit about persistent identifiers. ORCID is a persistent identifiers. A DOI of the articles is a persistent identifier. And there are many others now that are popping up, and some of them are becoming real standards in research information. So, starting with persistent identifiers, as I was saying to you, well-established persistent identifiers provide a trusted basis for open science. A PID, so a persistent identifier, is a set of associated metadata, has a set of associated metadata that is machine readable and must be structured as an URL. So this is the definition of persistent identifiers. And the persistence part of the persistent identifiers is related to the service, to the company that is offering the service, and not to the identifier itself. So this means that there is an organization committed to keeping the identifier resolvable, and the identifier leads users to the service that guarantees the reference. So persistent identifiers are used to identify who is doing the research, what is being published, what is being reported, and where it's being done. So basically we have identifiers for people, which is the ORCID ID, identifiers for things, which is the DOI for papers and for data sets, and we have the ROR identifier, which is used to uniquely identify institutions, organizations. So persistent identifiers allows for a more open science, a more interconnected science, and for that we need interconnected and interoperable PIDs that can talk to each other and can exchange information across the whole cycle of the research. So ORCID, Crossref, and Data Cite are the organizations that are behind these identifiers, the very well-established identifiers that we are talking about today. They are not the only ones, but they have become in the last 10, 15 years the standards in the community. And they have been working together for several years, and they have a joint proposal, which is a group of non-for-profit organizations. Their identifiers are always free for researchers and for contributors. This is the case of the ORCID ID. They are completely inserted in one part of the open science ecosystem, which is the open infrastructure one. They work for unique identification and for persistence of the information. They are community governed, they are sustainable organizations, and they are global organizations as well. So one important thing that you have been talking through these 2 days probably, and we'll talk a lot still, is the FAIR principles, which report to findable, accessible, interoperable, and reusable. And I'm not going to read all of these, but these are principles that are also a standard in the community. And I just wanted to highlight in each of these 4 principles, which is the data research output has to be findable, accessible, interoperable, and reusable. And inside of that, you can see the importance of not only persistent identifiers for data to be fair, but also the metadata. So in the findable part, for example, you see that data and their related metadata are assigned a globally unique and persistent identifier. Data are described with rich metadata because data sets is an important part of it, but the metadata that is related to it, that describes this data, that gives context to this data, is also very important. So here you can see that data and metadata and persistent identifiers are key components of the FAIR principles, which are important, very important in the openness of research. Oops. So this is only to illustrate to you that open science, when we talk about open science, we talk about open access, of course, but of course we talk about open data as well, and also other components, which includes open science tools, and open repositories, open services, and open workflow tools. And this is where the persistent identifiers are based. So these are key components for the open science. So just making a little bit of insisting a little bit about the importance of data and metadata, and this workshop is all about that. And I'm going to highlight the importance of DOIs, of digital object identifiers, for data and metadata. So the problem, we would say, the papers only tell a small fraction of the story. It is hard to comprehensively evaluate a research study based only on the paper. There are many fields in research that have complex experimental protocols and complex experimental data, and this may aggravate the reproducibility problem, which is a key parameter of research, is that data needs to be reused and the research has to be reproducible. So open and fair research increase reproducibility and reuse, and the infrastructure and the tools are available, but the adoption is still fragmented. So this is why we're still talking about it. So the solutions are the use of the identifiers. So a DOI makes research output uniquely identifiable and discoverable, and DOIs and metadata help fair research. So why it's so important to cite data? Citing data supports proper attribution and credit, supports collaboration and the reuse of data, enable reproducibility of findings, foster faster and more efficient research progress, and provide the means to share data with further researchers, with future researchers. Here, I just wanted to share with you, this is not so complicated. So this is, for example, an example of data citation. So there is the creator, the publication year, the title, the publisher, and the identifier. And it may also contain other information, but this is the basic information. So it's not that difficult to start citing data. So coming to the part of metadata, how is metadata used? So you can see here, this is a slide from Crossref. And you can see that metadata is key and important and used on all the cycle, all of the steps of the research cycle. So this includes the manuscript tracking, the hosting content, the bibliographic management, the library discovery. So all the different parts that compose the research life cycle. So here I just wanted to share with you a nice tool that allows your journal, your organization to track how good is your metadata. So here it's a Crossref service as well. And I just looked for the American Geophysical Union to see how is the metadata, how is being the process of depositing this metadata, right? So the AGU has 33,000 total registered content items. And here you can see, so here you can look for different organizations and journals, and you can see, for example, in terms of ORCID IDs, that 89% of the total registered items have ORCID IDs. There are other indicators that, for example, the funding award numbers, right? 55% of the items the AGU deposit on Crossref have a funding award number, and other information, funding registry IDs, for example. So this is the name of the funder, so the ID of the funder. This is the ID of the grant. So a lot of information. You can see the current information, the past information, so you can see an evolution, and you also can see the back files deposit. So this is to show to you there are many initiatives and tools that can help organizations and researchers to track and to better to adopt best practices in terms of data and metadata management. So how can I improve my metadata? So this is from a conference I was yesterday. Someone, Anatol Winska from Crossref, just showed this slide. So I am showing this to you because I thought it was very interesting to be able to motivate or to show how easy it is to improve the metadata. It's just a matter of thinking about this when we think about data. So identifiers are part of the solution, right? But they are not enough. It is important that researchers deposit reference metadata, that they add funding information, that when possible, include the ROR ID, so the Register of Organizations, together with the affiliation metadata. And it's important also to allow and encourage authors to share their ORCID ID using the ORCID API, which provides an authenticated ORCID ID, and to enable the auto update as well in your ORCID record. I will show you this a little bit further. The participation report is this tool that I just showed you in this slide. So you can, if you have access to this presentation, you'll have the link here. So there is another project that Crossref is developing, which is the Research Nexus vision. And so their motto is better research through better metadata. So the Research Nexus is a rich and reusable open network of relationships connecting research organizations, people, things, and actions. A scholarly record that the global community can build on forever for the benefit of society. So the idea is really to connect all the information so it is easier to find it, but also it's interconnected. So we have another level of information, which is the relationship between the informations. So I'm going to talk a little bit more about ORCID. ORCID is an acronym for Open Researcher and Contributor Identifier, differentiating with the researcher with the contributor, which can be whoever participates in the discovery of building new discoveries, of building new information. So ORCID is 10 years old this year, is, as I said before, a non-for-profit, a non-commercial organization. It offers an open code, an open API, and an open identifier. ORCID has a global vision and a global scope. It is guided by researcher privacy and control principles. I'll talk a little bit about this as well. ORCID is supported by their organization members that through the integrations with the API can add information and read information from and to your ORCID records. In 2019, so not long ago, ORCID reached break-even, meaning that it is an economically sustainable organization, and it's growing and getting more and more impact. Oops. Here. So here in the map, you can see in green countries where ORCID has consortium, and in blue you can see the direct members, individual members. So currently there are 15 million records, 15 million people that have an ORCID record. There are 25 consortia in the world. There are 1,200 members in 55 countries. The majority of these members, the majority of these members are in a consortium. The majority of these members are almost 80% research organizations, typically universities, followed by publishers, associations, funders, and governmental agencies. Currently, there are more than 4,000 systems integrated, so organization systems that are integrated with the ORCID API, and there are more than 6 million users that are giving permission to these systems to have their records, their ORCID records, updated automatically. So the ORCID services include the identifier, so the number you get when you register in ORCID, right? So researchers create their ORCID ID by registering to the ORCID platform. And also researchers populate and connect their records to databases and organization systems. Another service ORCID offers is the record, right? So you have an ID, but you also have a record where you can store information about your trajectory, your works, your affiliations, your peer review activity, your grants. You can add all of these to your ORCID record. And the third service is, as I mentioned before, a set of APIs that helps to connect and synchronize data between systems. So this is the virtual circle of ORCID, which is enter the information once and reuse the information often. The idea is that the researcher is in the center of this virtual cycle, and their employer, so their university, their funder, and their publisher can read information, right? Collect information from your ORCID record, but also can connect information, add information to your ORCID record, so you don't have to do this manually, right? So this is done as well by the sources of the information, which means that the information that is valid, that is inside your ORCID record, is validated by your employer, by your funder, and by your publisher. So ORCID is free for the researcher, and also becomes a hub between systems with information validated by the source. So ORCID is increasingly becoming a hub for a huge amount of registry activity and data. So you have the publisher systems, you have the institutional systems, the funder systems, and the discovery and profile systems, the researcher at the center. And here there are some numbers that give an idea of how ORCID and how widely, how intensively ORCID is being used nowadays. So for example, here you see that ORCID helped researchers sign into member system 48 million times in 2021, because several systems use ORCID as a registration possibility, right? You can use your ORCID ID to sign in different systems. More than, almost 2 million researchers benefited from members updating their records, so from organizational members updating the researchers' records with information. ORCID records are viewed 200 times per minute, so meaning that it has become a source of validation of information for us to look for other people. The ORCID data is read, has been read 170 million times per month, so by external systems, so meaning that users are saving time and in administrative burden. So ORCID welcomed 179 new members, including some important organizations in the last year. And this is an important information. 17 million items were added via the 500 integrations and by the 400 members. So this means that the integrations are alive and working well. I'm going to talk a little bit about the institutional ORCID integration, why they are important. The more renowned ones for you probably are the ones related to publications, submission systems like OJS, for example, but many other organizations and universities, as we showed before, are integrating with ORCID, which makes your life as a researcher much easier. So why the integration with systems is important? Because this integration provides an authenticated ORCID ID versus the researcher having to type manually in a field your ORCID ID, or copying and pasting the ORCID ID, which both actions may induce errors, because you can miss a number, or you can change a number by error, and the system doesn't work. So the OAuth process is important, so the organization collects an authenticated ORCID ID, and you as a user, as a researcher, you are sure that your correct ORCID ID has been shared with the organization. This authenticated ORCID ID, and only this one, gives permission to the organization to read and write on your ORCID record. And in this process, the organization becomes a trusted organization. And you can see in your ORCID record settings, you can see all the organizations to whom you gave permission at one point to collect your authenticated ORCID ID and to add information to your ORCID record. So these are the two screens that you get when you authenticate your ORCID ID. So you create here your ORCID ID, you register, you create, and at the following step, you give permission to, in this case, the Universidad Nacional de Costa Rica, to this organization can read information, can update information in your ORCID record, and can create or update the information they previously added to your ORCID record. So this is the screen that you get when you are giving permission to an organization to interact with your ORCID record. So more than typing your data, you have to find this button here that means that the organization has a valid integration with ORCID. And when you click to this in this button, you create, or if you already have an ORCID ID, you create and connect your ORCID ID to the system. So we were talking about visibility and privacy. All the items you add to your ORCID record have independent visibility section, meaning that you can choose that these precise information. Sorry, my mouse is very delicate. So you can choose that if this information is going to be shared with everyone that consults your ORCID record. Limited, only your trusted organizations can see this information, or private, meaning that only you can see this information. So here's an overview of the ORCID record. I'm not going into the detail of it, but you can see when you create your ORCID ID, you receive not only an ID that uniquely identifies you, but you also have access to this record where you can include all your emails. By the way, we highly recommend that you do that, even the emails that are not valid anymore, because eventually you were in a university, or you were doing a postdoc or something like this. You are not linked to this university anymore, but you eventually published under this affiliation. So this means that it's important that you add all of these emails here, all the variations of your name. So you have here your name that you decide which is going to be, and also because this is configurable, and you also can add all the variables of your name. So in my case, what I've done retrospectively is that I took all my publications and I added here all the variants of my name that the publishers added to my publications. So I didn't invent this. This is how I'm being called by different publishers a long time. So in this record, you have the possibility to write a short biography. You can add your employment, your education and qualification, your invited positions and distinctions, membership and service, if you belong to a society, for example, your funding information, your research resources that you are using. So if you are using a machine, for example, to do your research, you can add this here, your works and your peer review activity. So all of these fields, you can add information manually, or you can add information by adding the DOI of this object or the ROR of this institution, or you can also import this information from some of the databases with whom ORCID has partnerships. So you can import directly. You can add your other IDs, your websites, and all your information here. It is important as well that you allow update for works from Crossref and Data Cite. So when you have a new paper that is deposited by your publisher in Crossref, or a new data set that is deposited on Data Cite, these two organizations can add this information automatically to your ORCID record. So you don't have to do it yourself. For this, you have to give these two organizations permission to do that. So you can do this on your settings as well. So this is the auto update in action, meaning that the source, so this is part of your ORCID record, right? It's one screen from your fictive ORCID record, but you can see here that there is the information and the source is Data Cite. While if you have put it yourself, the source would be, in my case, Ana Heredia, right? Which is has less power than if it's Data Cite saying that this information is valid, right? So I would like to propose an exercise, okay? And after that, I just have a couple of slides to finish. I would like to invite you to share your ORCID ID. So I'm going to put this in the chat. I don't know how you can have access to that. I don't know if we can actually do that, but I invite you to follow this link. Is there any other place I can share it? I'm not sure. So if you go there.
Anna.
Yes.
Just give them a moment. Okay, everybody, computers, phones, whatever. This is the big moment. This is where your ORCID becomes a thing. Phones, computers. Okay, you're all there. So can you see the URL? Yeah? So share-my-my-id period ORCID, ORCID, not the flower, .org / capital P. I don't know how this translates in Portuguese. I have no idea what you're going to type, but I'm going to try.
Eu posso fazer o português.
Ana, can you say it in Portuguese? I mean, like, really?
Então, share, né, tracinho, my, tracinho, id, ponto, ORCID, ou seja, share my ID, né, com um tracinho no meio das palavras, ponto, ORCID, ponto, org, barra, P maiúsculo, P de pato, o número 6, a letra A, o número 5, a letra M de mamãe maiúscula, o número 8, a letra D de dado e a letra L de lua maiúscula.
That was clear, right, guys? Yeah? Okay.
I'm
Did
going-
everybody,
I'm-
if you got into the website, hands up. If you need a repeat, keep your hands down. Okay, there's people who are like,
normally-
what did she say? Okay, we got one,
Yeah.
we're good. All right. And that's what
You
it's
have
supposed
to
to look
get
like.
to a screen like this. You have to reach a screen like this.
Okay. I think we may have left some people behind. So can you go back a slide?
Sure. Let
Okay.
me just, oops.
And so
Here.
actually, can you make your screen really big so they can see the URL? It's like maybe leave it in the mode you were in,
Yes, okay.
and
Just let me know when you think we are ready to go to the...
you guys can't see that. Okay, they're super far away from the screen. If you pop back into like edit mode and expand,
Make it bigger.
yeah, go big.
Okay.
Okay, there we go. Is that
that better? Or more? Woohoo, it's so big.
There we go. Okay,
it
so
does-
here's
it-
the front end.
You can see? Can you see everything?
So we have the SH is missing. There we go. There we go. All right. Okay, very slowly. Do you have that part? They now look like they may have the whole thing. They're looking more anticipatory, or there's a moment of eye roll. I can't quite tell. And then
Or they're
shift to the right.
meditating?
Orchid.org with no H / upper and lower matter. So the case of the letter matters, as you all know. Okay, now who has it? Okay, ooh, it's better. Okay, go ahead, Anna. I think you hit nirvana. Go for it.
Oh, wait a second, because now I'm lost in all my... So you should have reached a screen like this. Oh, can you see my screen, right?
Yes.
My screen with share my ORCID ID,
Yes.
where I'm moving. So you have to click here, add my ID. Right? In my case, I already added mine.
So why are we adding?
You're adding your ORCID ID, so you're going to a screen. You're
So
adding an ORCID ID to a list.
So if I don't have an ORCID yet, though,
You
which
can create
many
it
of us don't,
here.
so we have to start with register. So you would go to orchid.org and register, right?
No, you just from the screen we
Yeah.
were. Okay. So from this screen, we are going to collect the ORCID IDs of everybody that is there.
Perfect.
Okay?
That
But
is-
we are not collecting it manually, as I just said. So we are collecting that by the process of the OAuth. That is what I want to show you.
I love
So
it.
if you click here, add my ID, you will automatically go, because I'm live with you here, right? If you have an ORCID ID like me, you just enter your ORCID or your email and your password and you sign in, okay? If you don't have an ORCID ID yet, right? You don't have an ORCID ID yet, you go to register now, which I'm going to click. And then you create an ORCID ID in 5 seconds. You put your first name, your last name, your primary email, you confirm your email. Eventually, you can put your another email, and then you go next. And then we should arrive to this again.
So who has their orchid? Who needs more time to set up their orchid? Who could care less about an orchid? Oh, don't you dare raise your hands. All right, I think it's coming along.
Okay, if there's one person, I'll be happy.
Well,
I know it's not easy.
Strangely, I didn't actually write down the URL, so now I'm at the big P and I'm the capital P, and I'm not sure what the rest of it is.
We have 14 already.
You have 14?
No, we have 14 already, and add my ID.
You did it all. You all did it.
Fantastic. Let me see that. Oops. I'm lost in all my
Okay, well, Anna's doing that. Can somebody read to me the rest of the URL? Capital P and then something else?
I am trying to find myself here. I wanted to see.
The battery's all running out of our mics, by the way, for the folks upstairs. Oh, you have it? Okay.
Yes, we do have. Here. Can you see?
Papa, yeah, capitals.
Yep, go ahead.
Papa 6, Alpha minor, yep, and then 5, then Mike uppercase, 8, and Delta lowercase, and L as Lima uppercase.
Okay.
Let's see. No, wait.
Okay, I
Share
did.
my ID.org ID. Share / my ID. Yeah. Here you go.
Oh, you guys, you all did it.
This is fantastic. I'm happy. So this is the OAuth process, which is completely different from typing your own ORCID, right? Or copying and pasting, because this means that I have, right? We have the authenticated ORCID IDs. Okay, this means that the system, the API, collected your authenticated ORCID IDs. Shelley, you are here. Congrats. Thank you.
I got help.
So this is the way systems should collect your ORCID ID, okay? Because this is the only way we are sure that this is the right Márcio Teixeira, the right Sergio, the right Pedro, the right Aldomar. And thank you all guys for participating on that. This was great. And after that, we can, the administrator of this list, this is a beta thing from ORCID, right? This is just to demonstrate, or for small organizations like the PARSEC project, to collect the authenticated ORCID IDs of the researchers, okay? So this is just to show to you why it is important to authenticate the ORCID IDs. Can we move forward, you think, Shelley? Or people are still...
No, I think they're all in. I think they're like holding their breath for what you say next.
Okay. So I'm finishing soon. I just wanted to highlight that ORCID and the other persistent identifiers that I mentioned are being more and more included in policies and guidelines, right? So it's really a matter of compliance now for some organizations. So just to share with you that many governments and funders are adopting ORCID as part of their national research strategies. Here we have the National Institutes of Health in the US. We have the UK Research and Innovation, UKRI, the National Secretary Funder of the Republic of Panama as well is demanding ORCIDs in several of their processes. The European Commission, here there is specifically from the European Commission their recommendation that the European Research System and Open Science Cloud, EOSC, should adopt ORCID as its preferred system of unique identifiers, and an ORCID ID should be mandatory of all applicants and participants in this program, the FP9. Here, it's also the European Commission that released in 2020 the guidelines to the rules on open access to scientific publications and open access to research data in Horizon 2020. They are also recommending that identifiers that are persistent, non-proprietary, open and interoperable, like ORCID and Data Cite for data identifiers. Here, there is another document from the Coalition S, the Plan S, which includes as well the support for PIDs for authors, funders, funding programs and grants, institutions, and other relevant entities.
Anna.
So yes.
So I know we're coming right up on time for Leslie to start, but I do have a question from Solange.
Yes.
And actually one from me. How many journals, so we have students that are going to become published authors any second now. And we have been telling them that the journals require ORCID. How many are members of ORCID? Do you know a general number that we can throw out?
I wouldn't. Yeah, it's thousands, I would say, are using ORCID, right? Not necessarily they are members, right? Because there is the free API, so the public API. For example, OJS, right? Which is not a publisher, but it's a submission system that is widely used here in the region, Latin America. Almost all the journals use OJS. OJS has a plugin that allows the editor to collect the ORCID ID and through the public API. So there is no need to be a member. I wouldn't know. I know that, like, from the data that I provided here, 7% of the ORCID members, the organizations that are members of ORCID, are publishers, okay? Yeah. But I would say that more important than that is how many journals are requiring ORCID.
Yeah, and some of those publishers have tens of thousands of journals. So I think for you as researchers, the answer is expect to give your ORCID when you submit your paper, and then
Absolutely.
the beauty is you get automated attribution and credit coming from that. So that's really the key. And then Anna, I know we won't have a whole lot of time for questions, but we can certainly share your email. But Solange and I were talking about ORCID really supports privacy of your information. So the default is not public. And what happens is you'll set your ORCID up, and yet I still can't see you until you let me see you. And please don't make me call you to open up your ORCID. We need you to actually share what you're willing to share. Like, for instance, you do not have to share your email. You can protect yourself and not. Some folks that are from vulnerable communities actually don't share their email, so they don't receive unwanted email. However, as comfortable as you are, try to share as much as possible. As I said earlier this week, this is how I find you. This is one of the places where I can search for certain things and identify you as a possible board member or a possible member of a working group. And I also want to be able to email you. So if you can share something you're comfortable with, that's beneficial for all of us, because then I can get to you easily. But if you're not comfortable, that's okay too. There are cases where that is something to keep in mind.
We can share whatever we want. In fact, in my case, for example, I have everything there because it's a way for me as well to, and I can share with different people different parts of my ORCID record, right? Because you can export it as well. So not only you can make it visible or invisible to people to look at it online, but also you can share it, different parts of your ORCID record with different people. An important thing that I wouldn't like to miss, since you mentioned that, Shelley, is that, for example, doing research for my consultancy, sometimes I get into a project, for example, and there's the project lead, and there is no information about this person, and I would like to know who this person is, to which university this person belongs. So it's a way of identifying yourself, and also to allow other people to know that you are a person who is really working on that field, right? That is really a person who is active in that field, versus someone who just put their name on that. And I think that the quantity of information, the quantity of data that we have now needs for more validation. One of the key things at the moment in terms of research is trust in research and transparency, right? Because we have so much information that these validating tools are very important. And I'll leave you there because I talk too much.
Oh, no, this was so useful. So is there anyone who's here or online that has a question about ORCID? We tried to be really thorough, so hopefully you have everything. Nope,
for those who are interested, there is the PID forum, right, that I want to share with you, because there are many things being done in terms of PIDs.
So if you love things that link together and you're all into linked data and using persistent identifiers, there is this persistent identifier forum, PID forum, and all the persistent identifier geeks are there, and they're a lot of fun. All right.
Thank you so much.
Anna, thank you so much.
Thank you.
All right. So our next speaker is Leslie Wyborn. So full disclosure, I've known Leslie ever since I joined AGU. And Leslie has been that kind of person who has been my mentor and making sure that I understand the impact that AGU can have on the informatics community. So it's my delight to introduce you to her as she talks about the different communities. Leslie is an adjunct fellow with the National Computational Infrastructure faculty and part of the Research School of Earth Sciences. She's affiliated with the Australian National University. I think it's 2 a.m. where Leslie is, by the way. So this is like a really amazing that she's here with us in real time. She has spent over 42 years, let's just say over 40, we'll round down, in the geosciences, working within the government research sector, and her expertise is across geoinformatics, computational geoscience, granite geochemistry, and related I don't even know how to say that word, metal stuff, things with metals. How's that?
Metallurgy.
Thank you, metallurgy. And the national scale mineral systems analysis. And I could go on because she is that kind of person, and we could talk about who she is for about an hour, maybe two, but I think better for you to get to know Leslie. So welcome, Leslie. Take it away.
Okay, can you see my screen now?
Perfect. Go right ahead.
Okay, so I've been asked to give you all an introduction to some open science organisations, particularly RDA and ESIP, and I've thrown in a couple of others, but Shelley's kind of given it to you. I do work with the Supercomputer Centre. I do work with the Australian Research Data Commons. All this is part-time. And I also work with the Australian Infrastructure for Earth Sciences scope. So I kind of have a background in building infrastructures at an international level. So before I start, I'd like to acknowledge the traditional owners of the lands, seas and waters of the areas that I live, work and meet on. And I acknowledge their continuing connection to their culture and pay my respects to their elders, past, present and future. So my outline of my talk,
Leslie?
I don't know how many, yeah?
I know that sometimes your internet connection is not ideal. Do you mind turning off your video? We had a little bit of a glitch.
I'd love to.
Okay, wonderful. Please go ahead. Thank you.
Yeah, I prefer that because I'm at home at 2 a.m. I'm not going into the office and my home computer's not very good. Okay, so I'm going to just give a quick recap in case you didn't hear my talk the other morning on Belmont and, you know, what drove it to do global infrastructures, why it's important to work internationally in the open science community, and introduce you to Research Data Alliance, ESIP, CoData. And I'm going to say my last slide will be a pretty thought-provoking question. So there's really a bigger picture beyond PARSEC and beyond the Belmont Forum. We have grand challenges that all earth and environmental science data contribute to beyond our immediate project. But our data will need to be fair. And interoperability is the difficult, or we call it the killer one. That is, how in machine to machine do you interoperate your data? And Margaret kind of touched on that, and I think she's going to say more when she talks on vocabs. Because to be machine readable, you've got to have an understanding of the terms that you are using, and they must be expressed in machine readable forms. And so the limit to sharing data globally, and I always tell people this, the size of the community that you can interact with and exchange programmatically any data is only as large as the size of the community that can read and understand the same standard. So if you've got 3 or 4 people that can interchange data, that's great, but that's as far as it'll go. And if we want to contribute to international global challenges, then we've got to start getting those groups to be bigger and bigger. And so we need our data collections to be reused and repurposed, be machine readable, which means when we're talking about these standards that our community can share, they need to be globally agreed, and they are fundamental to allow programmatic sharing of data both within and beyond. So I'll come back to you. Think when you're trying to share data and you're using a standard, how many people use that standard? If it's local, then I will make the grim prediction that the persistence of your data over time will not be really all that great. Why won't it move? Now, I'm working on a project called One Geochemistry, and I just thought I'd illustrate it with that, where our current state is we have multiple human readable systems. Some have metadata, some are fair, but they're only fair within that system, right? We can't interoperate multiple systems because the community's standards that being used are just too small. And so 4 big geochem databases from Australia, EarthChem in the US, and EPUSP and GeoRock from Europe are attempting to harmonise our systems, but it's still really human readable because, embarrassingly, and I say this because I'm a geochemist, there are no agreed community standards to make that data interchangeable. We can put metadata on it and make it findable and accessible, but then we have to download it and go through lots of toil to be able to reuse it. And so our future state we're trying to work towards is multiple machine actionable systems compliant with these standards and all fair to both human and machines. And so what we're trying to do is to invigorate the international community to recognize the problem and start developing just the simple vocabs, the minimum variables that describe our data. And hopefully we'll bring geochemistry out of the dark ages. And so we need these silos to come together, but how? And we look for history in building infrastructures, and we know pretty well that one size will never fit all. And so, as we have done with when you go traveling and you have to change your power socket or in those days, well, you probably do more of it catching trains, we can see that we're down to, say, tens of standards. We'll never get down to one, but you can't have thousands, because if you have thousands, you will not be able to share your data beyond your project. And so our starting premises, what I'm going to say is that in any infrastructure, one size does not fit all. And I come back to it. The size of the community that can programmatically exchange any data or information is only as large as the size of the community that could read and understand the same standard. And so in the beginning, it was recognized with Belmont, because it actually ran for a couple of years before they suddenly realized that they couldn't share the data and information from project to project. And so they got a group together to develop a community strategy and implementation plan to develop the necessary infrastructures and data management regimes that would enable Belmont collected data to be used by, say, Belmont and the Future Earth project. And we did a survey, which we had 1,300 responses, and we targeted all types of earth and environmental scientists, as well as social and economic sciences. And we wanted to know what were the key open activities communities were dealing with in global environmental change and who had the best practice. So again, we were trying to find those big communities. We wanted to look at areas where perhaps it wasn't a big community, but how could we help it by enhancing it and make it bigger? And we wanted to identify barriers to open sharing from either a data provider or a user perspective. What was it? And so the results of this survey are here. And the important point is not only were those 1,300 responses, they were from quite a few countries. And this is where it sort of became what is now an integral part of any Belmont project. And as Shelley explained with the DDOMP, this is why it's there, because we want to make your input into the Belmont project PARSEC, we want to make that reusable. And so it has to be open. We want scientific merits for the motivators. We want training and support activities. But the really important thing was Belmont recognised that interoperability between infrastructures should be facilitated. It should take in general requirements, because there are a lot of generic things that you can share across systems, say a vocabulary for units of measure. But you also have to respect that when you're trying to bring data together, there are disciplinary norms and standards that have to be respected. And you can read this because it was 2015 and it was the summary of what we were recommending to the Belmont Forum. And you're hearing a lot of that here today. Adopt data principles that enable global interoperable infrastructures, foster communication and collaboration within a wider community. Don't just do it within a local university. And the good planning and stewardship, that's the DDOMP. And demonstrate international best practice, because Belmont, as Shelley said, was bringing 4 or 5 countries. So we can't have each country in a project developing a silo. It has to be international. And then also get a cross-disciplinary training curriculum. And as we say, they then became part of what was Belmont. And so now I want to introduce you to some other groups that also had similar philosophies and started about the same time. So the Research Data Alliance was launched as a community-driven initiative in 2013 by the European Commission, US NSF and NIST, as well as the Australian National Data Services. And so those 3 countries, those groups from those 3 countries were all groups that were building data infrastructures. And the idea was collectively, if we work together and share where we're developing the same infrastructures, say for recording provenance or data versioning or management of samples, why do it separately in each country? Let's bring the working groups together and see what we can come. And since 2013, it's now grown to 10,000 members from 145 countries. And it's a neutral space where you can come together and develop and adopt infrastructure that promotes data sharing and data-driven research. Part of the background also behind these three countries coming together was because each of them only had a limited pot of funding and they couldn't fully fund it to be developed in their own country. But if you put the three pots of money together, we could actually accelerate and do something. And it holds hybrid plenaries, and just letting you know, the next one is in 21 to 23 March in Sweden, in Gothenburg. And it's a decade of data. So RDA works bottom up through groups. It tackles numerous infrastructure challenges through the work of 43 working groups. So that a working group is a group that forms with a particular task to complete within 18 months. Associated with that are what we call interest groups that can go on for a lot longer time, where people share and you're interested in a topic and you just want to be there and chat through online chats, Slack, or at the plenary meetings. Just share and let people know what you're doing. It's free to join for an individual, and I can assure you within those interest groups, just about any topic is covered in building data and software infrastructures. And if it's not there, then go and form a group yourself and get it going. And so in the Earth and Environmental Sciences, Pedro Shelley, along with Danny Kincaid and Helen and I have formed this, are chairs of this Earth, Space, Environmental Science interest group. And we meet to spread the word on Earth, environmental and space science projects anywhere. And we have two main catalogues. One is of data infrastructures, and the other is that incredibly important thing that we have to progress for interoperability to work, which is a catalogue that lists vocabularies, ontologies, and semantic models relevant to Earth, space, and environmental sciences. So please, I'll share my slides and put them in the folder. But if you've got a project on either an infrastructure or a vocabulary, please check it out and make sure you enter yours in so that we've got you recorded as a resource that's contributing to this global building effort. But more importantly, please contact us if you would like to highlight your project at our next plenary, because we do have space for new projects or sometimes have deeper dives on more detailed projects. And I know PARSEC has been highlighted at several of our meetings. So please do join us. And as I said, there's lots of other groups. There's data versioning, there's samples, there's sharing results, you name it. You just got to look at the inventory of them. And the important thing is that you join a mailing list, and that puts you in contact with international experts. And if you're a young student or postdoc, it's a wonderful way to get yourself engaged and, more importantly, known within this community and contribute to it. Earth Systems Information Partners, it's a community of 120 partner organisations and volunteers, but it's much more focused on environmental and earth sciences. And it's similar to RDA in that it has what it calls clusters, which is similar to the working groups and 6 committees, and there's the full list. And it's funded or sponsored by the USGS, NASA, NOAA, and there are many, it is mainly US based, but there are definitely groups in there. So there's about 8 Australian groups, including my own groups, all three of them, ARDC, NCI and Ozscope, are all part of it. I like to also highlight a couple of other groups. And so again, it's these big groups that are providing that international perspective and trying to actually move beyond the project and be able to integrate your data at an international level. And so GEOS is more related to national governments. It has 100 national governments and in excess of 100 participating organizations. And it's about integrating observing systems and share data by connecting existing infrastructures using those higher level common standards. And it has over 400 million open resources in GEOS from 150 national and regional providers. Another one I'm closely associated with is CODATA, which is the Committee of the International Science Council. And the Science Council is where all your unions are, like the International Union of Geological Sciences or International Union of Geodesy and Geophysics, International Union of Chemistry. And so they actually have the really high-level experts in that field of science. And strategically, what we're trying to do is to get the scientists much more engaged in endorsing the vocabularies, the semantics, the semantic models, and the ontologies. Because what's happening at the moment is, because of the importance of vocabularies to interoperability, machine readability of data, is springing up everywhere. And you don't know the pedigree. You don't know how good a particular vocabulary is. It's kind of like Margaret showed the 5-star for linked data. We've got a 5-star for vocabularies as well. And where we really need is for the scientists to get involved and help us to endorse and say, yes, that vocabulary is scientifically valid and is the one that you should use. So in pursuit of all that, they have a decadal program making data work for cross-domain challenges, as well as the Global Open Science Cloud Initiative, which is an international activity to bring all these science portals, all these producers of data together in a cloud that is interoperable and reusable. It has a data policy group that promotes principles, policies, and practices that help ensure data are fair. It is also exploring, because data science is rapidly changing, how you store and exchange data is evolving through time. And its biggest challenge at the moment is it needs to scale to be able to cope with petabytes of data. And many current systems we know will not scale. So what's the next generation? And CODATA is researching that. But above all, again, as with the Belmont, the emphasis is on data skills, building capacity for open science by improving the functions of national science systems needed to support open data. And I'd like to introduce you now to this other project, which is a joint project led by CODATA with RDA as a major partner. And it was funded by the European Horizon program. And what we've got is a consortium of 19 partners from around the world, and it features 11 case studies, which I have listed here. And so if you look at the outer circle, we're all trying to work together to make our data fair, with a particular emphasis on interoperability, vocabularies, and reusability of data. And then, as you can see in this darker circle here, we're trying to work out that interoperability framework to enable you to do cross-domain data. And through that, we're going to use, I won't go into it, but it's something called a fair implementation profile, where for each data set, you list what online resource you're using, like for your metadata, or what vocabularies, what provenance system, so that we get a data set and it's all there declared, and it helps it make the data machine actionable. And we, as I said, will contribute to these global interdisciplinary projects such as the UN Sustainable Development Goals and the Decadal Program. And we're testing the idea of this inner circle of how you actually make the data interoperable. But again, as was part of that Belmont paper in 2015, we still need to respect the deeper discipline scientific research and innovation within individual disciplines. We cannot be so rigid that that gets compromised. And the case studies are grouped around themes. And again, this is how sharing works. So the geochemists who are so far behind in developing the required standards to make their data machine actionable and readable. And as I said, I'm a geochemist, so it's very embarrassing. We've discovered that chemistry with the International Union of Pure and Applied Chemists has got just about all the standards and vocabularies we need, because geochemistry is chemistry where you're analysing the geo part, which is usually a lump of dirt, a bit of soil, or some fragment of a rock. But again, the important thing is that the more we can reuse existing standards from somewhere else, you can start to see how we can make geochemistry and pure chemistry interoperable. And so the limits on sharing data, I'll come back to this slide and I'll say it again. The size of the community that can programmatically exchange any data or information is only as large as the size of the community that can read and understand the same standard. So I told you I was going to ask you a question at the end. The original aim of the Belmont Infrastructure and Data Management Project that ran from about 2013 to 2016 was that data and information of any Belmont project would be part of a global infrastructure and data management system. And so my question to you is, if data and information from PARSEC is integrated together, and I can see that happening, it's really great. But will it contribute to the rapidly emerging global environmental infrastructures developing within and beyond the Belmont Forum? So my question is, how closely aligned is what you're doing within the Belmont Forum with what is going on internationally elsewhere with these bigger programs such as RDA, CODATA, Geo, World Fair, etc.? But I will say, without being too harsh, integrating beyond current boundaries can be very challenging. I've been there and done that many times. Thank you.
Leslie, thank you so much. That last question, are you directing that to the students in the room? They're probably wiggling in their seats right now going, oh, we have no idea. Or is that something you want me to answer?
Well, I'm just directing it to anyone who's working on Belmont Forum and asking, have you actually considered, like, you're working hard to integrate your data across Brazil, France, etc. But what about that bigger picture for the same data type? Has anyone considered it?
So you did a 101 class and you just asked like a graduate level question. That is unfair, Leslie.
I'm sorry. Okay, well, I'll ask people like you then. I won't ask the students. I just wanted to highlight, okay, the really purpose thing I wanted to do there is say there's a bigger picture that's going on.
There we go. That's it. You were making a point. But okay, so I'm happy to
hang on. No, the second, sorry, I just got a message from your organizer asking me to turn my video on. Okay, so the second thing I wanted to say to you as students, I mean, I grew up in the pen and paper era, none of this internet stuff or easy travel, you know, like trying to do an international telephone call 40 years ago was nearly impossible if you worked for a government organisation. I'm saying to you that all these resources are online, and if you've got an interest, all you got to do is dial into RDA, see if there's a working group, join it. Have a look at what CoData working group is doing, and you will be immediately in touch with the expertise. It's like it's the democratisation of knowledge and expertise. And certainly as a student, I didn't have as easy access to this as what you guys have. And so I just wanted to say to you, there are these resources out there and you should definitely try and tap into them.
And that is an absolutely beautiful thing to say. So does anyone have any questions for Leslie? All right. I'm willing to dangle on the end of the string, though. So Leslie, as you know, PARSEC does not generate its own observational data. Everything is reused. So for all of our papers and publications, we cite the original source. We store our aggregated synthesized data into the Environmental Data Initiative, which uses the best data stewardship out there, full curation, beyond measure, aligning us to the best vocabularies, right, Leslie? So we've done the best we can, but honestly, anyone trying to do that in your own footsteps, we know that path is difficult. So did I answer your question?
Yeah, could I congratulate you if you are making the effort to credit the fact that you're reusing source data?
Yes.
Because as I said, I work on a big infrastructure where we store large volumes of climate data and satellite data. And the number of people that download that and then create a data product, which is really nice, then they write a paper, but what they cite in their paper is their data product. They don't acknowledge the source data set that was used.
So Leslie, being my mentor and a renowned expert in data sharing, software sharing, there's a number of things you've shared with me over the years that are just absolute important things for researchers to know about. So I'm going to poke a little bit. We have a couple minutes. I'm going to poke a little bit. Can you share, please, when they are planning, when they're creating their data management plans, or if you're Belmont funded, it will be data and digital output management plans. When you're creating them, and it comes time to, and you've done a really great job making sure they're fully backed up, documenting along the way, what should they cite in their paper? So we're jumping from this question you just answered on citing your original sources to can you list out, be sure to include the following things in your paper, and can you fill in the dots?
Okay, so the most important thing, because the funders, this is a huge issue at the moment, the funders are demanding evidence or reporting on who has used the data, where they're from, and what they used it for. So if you took something out of a major repository, then I would suggest that that artifact is your original data source, but knowing how horrendously big it would be, and I think you mentioned this earlier, you just need to say, I cited this data set using this query. Because you don't need to keep a copy of the data set that you've downloaded from a fully fledged stable repository. Then I'm going to talk about science because, you know, this data stuff didn't exist in my era when I started. It just, like, my joke is, as a geochemist, a student can do about 1,000 analyses. We did in a PhD, geochemical analyses. We did it by hand, and it'd be 10 in 3 years. But anyway, sorry, I'm digressing. What I'm then saying is that you then produce a product. So this is the open science. A true scientist is one whose data and conclusions are reproducible. So I need to know what software, what version of the software you used, and all the bits and pieces on the source data to replicate the output that you got. Then the third component is the output itself. And I think when you do that, the repositories should be smart enough, who've got the source data, to record who funded that, and, you know, with, as, you know, the cross-ref IDs and the ORCIDs.
Yep.
And then that carries with the DOI for the data set. And so then the big repositories can start to provide evidence of their value and that they are being used.
Yep. So attribution back to the repository, attribution for you having used it. Yep. So it's a whole circle.
And I'd also strongly recommend, there's a couple of things for you as young researchers, is it's important, as the previous speaker said, to get your ORCIDs in, particularly on the data sets, right? And have them well documented so that you can get credit for them.
And Margaret grabbed the microphone from me, so I know she's going to expand upon our moment. Go ahead, Margaret.
Hi, Leslie. I just wanted to add a comment to your statement about repositories and data provenance. A reputable repository can record the provenance of the data sets that it has. So if a researcher posts a data set, like with us, with EDI, with Pangea, with most of these large ones, we can record, and then they say, the source data for this derived product is data set X, Y, Z, several of them over here in another repository. We can record that. And so yes, using the citation for your product data set in a paper is, I want to say, should be good enough. There still needs to be some connections made between the repositories so that if there is provenance that should be followed, that it actually happens and the original source actually gets credit too.
Thank you.
Yeah.
Thank you.
And then the other thing too, which is coming in, right? Because this is particularly important in environmental data because it's longitudinal and it lasts forever sort of thing. When you record your data set and you say, I've used vocabulary X, you should also timestamp it so we know which version of which vocabulary we used. I mean, it's all about reproducibility. And just also catching on with what Margaret said, yeah, Margaret, I do agree that good repositories are now starting to ask for the provenance of the data, but a lot of journals aren't. And so there's a lot of papers that have downloaded data from the big repositories, but they're not acknowledged in the paper. And the third component too is repositories have got to wake up to this because often they change a data set or or they correct a data set or they modify the data set, but don't do a proper version release. And so if they don't timestamp changes they're making to the data set, particularly if they're significant, then again, you can't reproduce the data set.
Leslie, thank you. I think we're coming to the end of our session. This has been incredibly valuable, and we are so grateful that you stayed up so late and appreciate your time and your expertise in sharing that with us. I hope you have a good sleep, and I'm sure if there's any additional questions from this session or later, we will ferry those over to you for answers. Great.
No problem at all. It's actually, it's not staying up late, it's staying up early morning.
Thank you.
Okay.
So. All right.
Catch you later.
All right, bye-bye.
Bye.
Okay, so thank you, Shelley. Thank you. And I guess this is lunchtime now, so you're welcome to join us at 1:30, I think, for the at least the students.
Just
in
a
this
second.
area.
Hi. Well, we'll have a hands-on activity after lunch, right? So we will need, you will need internet access for that. So if you need a password to get access to the internet, please come to me a little before it will start at 1:30, so come 1:15 here. I have some passwords and I will distribute to you, okay? If you need, look for me here. I'll be right here. Thank you. Hello, one?
Bonjour.
Recording stopped. Recording in progress. Recording stopped. Recording in progress.
não, c'est fait.
works. Okay, so we are going to start. So if you please be kind to come here closer to us. And if we will be only this amount of people, we'll make in this table. So that will be closer together, okay? So please come over.
You can start? Okay. Hi, and good afternoon. With the pleasure today, me and Jeannette, we will try to present more technically our project. As in the first day, we have presented just the goal of our project and the research questions. And yesterday, just we have presented some results of our project for East Africa, case study, United States, Australia, and Japan. And today, it will be more technically with some codes and some scripts to show you how from a satellite image you can estimate the poverty. Okay. For this, our talk today with Jeannette is to present all the pipeline from the data collection to poverty estimation. So you start by present the general context, and after that we will present the pipeline of deep learning for poverty estimation. And after that, Jeannette, she will present a case study of Val di Ribeira for all steps: data collection, data download, data preprocessing, using socioeconomic data and satellite image to estimate poverty in Val di Ribeira, Brazil. So the idea is to use the combination between deep learning and satellite images for many environmental applications. And today we will just discuss about the use of deep learning and the satellite image for poverty estimations. So for deep learning, application deep learning using Earth observation data, there are two challenges. The first is about how to select the best model, and the second is how to select the best parameters of our model. So for the context of poverty estimation using deep learning and remote sensing, since 2015 there are several works in the literature that use many satellite sensors to estimate poverty. For example, Landsat, DDOMP as the daytime sensor, Nightlight, and also Street View as another source to estimate poverty. So you can classify all methods in two categories. The first consists to make directly estimate the poverty using socioeconomic data and satellite image. You train our deep learning using satellite image and deep learning. The first category consists to use another additional information as proxy to estimate the poverty. For our work, as you have reproduced and replicated a recent paper published in Nature, you all have proposed deep learning-based methodology to estimate poverty in Africa. So you have used the GitHub of YIHO, but you had several issues and with this prediction for the reproducibility for this code, because there are many parameters are missing in the GitHub, and there are two links for the same work that we had some many issues, and just after this presentation, Janet have presented a presentation about the reproducibility using deep learning methodology for poverty estimation. So the pipeline, as you see here, here from socioeconomic survey, the socioeconomic survey represent. Socioeconomic survey is a set of questions about if at household level, if family has electricity, has water, the quality of water, has motor, telephone, some question. And from this survey, you calculate the wealth index. The wealth index is poverty, just index of score that we at village level. After calculate the wealth index here and base it on the geographic coordinates, latitude and longitude, you can download the satellite images. Here in our case, we will use Landsat images, is multispectral sensor with 7 bands, spectral, RGB, and 4 other bands. And you have used also the night light. The night light is sensor with the same resolution, but in our case we have used 2 sensors. One sensor from since 82 to 2009, and another sensor from 2011 to 2020. After download the satellite image, there are some pre-processing steps for make some processing for the satellite images. Also, we have used a 3-year composition because it is difficult in Africa to find in Landsat images for without a cloud. For this, we have chosen to make to use the 3-year decomposition. Here for before training the deep learning, as you know, generally from computer science view, you have split the data randomly to train data, split train data, test data, validation data. But in our case here, we would like to propose a generalizable model. And in order to avoid the overlap between the satellite image, you have make some used an adequate method for split the data. And you have used a pre-trained CNN using ResNet 18, but you have used many configurations. For just you have used only Landsat images, and also we have used night light, and there are combination between the 2 sensors. So you have trained Landsat only, and separately Landsat and night light, and after that we have made a ridge regression to concatenate the features from the 2 sensors. So here, for our case, we have developed from used some scripts from YIH And finally, you have two parts. The first part using air. When this script you have used just to calculate the wealth index. Here you have used a package for DHS data. You have as input the countries and the data, what you need to collect the survey, and we will fund the survey based on the question that we have, and finally you calculate the wealth index. Before the second steps, here is all in Python. Here, after the first step is to download the satellite images. Here you make the split because here you download one image by country, and here you make split for the image by country, by village, by year. Okay, and here you make the training, and you save the model as checkpoint. After the training, you save the model as checkpoint. If you have some, for example, here to test our model, if you have other village, for example, just you can use the the geographic coordinate, download the satellite image, and use the checkpoint to make estimation. So in conclusion, there are all our scripts, and I think we will share the script as soon as possible with the scientific paper and GitHub link. If you have any question, you can stop me now. It's okay for the methodology, okay. So now I will present each step for the used script. Here, as you know, for the deep learning experiment, it is necessary to check the packages. And it is, you had many issues that you have for the installation, installation of the package using TensorFlow and other geospatial package. That here you have all required packages for the execution for the deep learning model. As you know, you have just used pre-trained ResNet 18. Here, for example, it is represent the file of a CSV file for the wealth index. You have the country, the year, and the geographic coordinate. You have the wealth index value, and you have the number of household, because the wealth index was constructed on village level. Just for each village there is the number of household, and also the type of area, if is it urban or non-urban. You here our data set for Africa. You have used Google Earth Engine to download automatically the satellite image using as input the file, okay? And after that, there are some parameters to define the number of images that will be compressed. Here the chunk size. The second step, as you said, you have first of all download one images by country. So the first step here to split this image based on the village. So starting for one image by country, we will to split this images on village by village, by image, by country, by year. Here there are some examples for our data set, the number of the survey by country for Africa. Here an example for the Landsat images, the bands of Landsat images, and here is the nightlight images. Here, the step of data split that you have used to configuration to split the data, and also in order to avoid the overlap between satellite images. And you have used two configuration here is out of country that consists to assign one country for one split. Here the aim is to avoid to make the same information in two different split. So if there are villages very close, so there are overlap between the images, so you can't put the same information between the overlap of satellite image in two different splits. So the best solution is to assign two villages close in same different. So here for the solutions, the first solution is to assign or one country in one split, or there are another method that consists to calculate the distance between two villages. If the distance village are very close, you assign the village in the same split. Here you have before deep learning, you have used some machine learning baseline to test the process of estimation poverty using socioeconomic data and satellite image. Just here you have used KNN, and for the training, as I said, you have used two CNN. Two pre-trained CNN ResNet 18, and we have used a script to execute the deep learning. There is the same hyperparameters of deep learning, such as the number of epoch, how to the method of optimization. All parameter learning rate, all parameters. Just for the deep learning, you have used just script, and this script is only for one type of images. But after that, you use the features extracted from the two CNN for each sensor, and make a ridge regression to concatenate the features from the two CNN and make estimations. So now Jeanette will present, and you present the case study of Val de Ribera, and using the same methodology, the same pipeline. Okay, thank you.
Okay, thank you, Ali. So probably if it is working. And yeah, okay, now I'm sharing my screen here. But and just a little back, because I have the slides, if you could come back. Yeah, okay. So the case study, it's in Valle de Ribeira. So this is a small hands-on we are going to do. And since Ali has showed you the 6 steps for making the full workflow pipeline for deep learning with this satellite image. So we have a case study, Valle de Ribeira, which is this town, the census tracks with this area. Okay, so we have seen this yesterday with the case from Valle de Ribeira, which is on the south of São Paulo and some part of Paraná. What is interesting from here and what we are going to do is that we have the lowest granularity, which is this, census tracts. All of this is the lowest granularity for collecting surveys with the IBGE. So this is the geopolitical separations in Brazil. And each of these is one municipality, so we have 30 municipalities and kind of almost 100 census tracts. Okay, so we have almost 100 census tracts. Besides that, we have also calculated a computation of these 3 indicators, which is income, longevity, and literacy. So we have, this is, I'm not going to show you, but we have in another GitHub that I can share with you, we have how we calculated these 3 indicators for this same area, Vale do Ribeira, how we collect the surveys from the census of 2010, which is the recent census, and how we calculated these indicators. So these ones are values normalized between 0 and 1 for these 3. What they measure is the well-being of this population. Okay, so this is the observed socioeconomic indicators for Vale do Ribeira. Okay, so longevity, literacy, income, and if you're not seeing here, it's from 0 to 1, so it's normalized. Okay, and we have this data set that we are going to provide you for this experiment. So now, wrapping up, you have to go to this link. I don't know if you can go here, but it's okay here. GitHub, the /parsec world /WDS6 hands-on. Okay, please go everybody on this link. If you can see the QR code, you can go as well. And now we can share my screen, please. Yeah, yep, the link. Yeah, better. If we come back to the slides, please. Yeah, production. Yeah, here it is, parsec word /WDS6 hands-on. Our QR, it's if this working, you can do it. No, it was a surprise for me. Okay, so now to the control, go back to the Zoom. Okay, so what we are going to do now is to so we are on the website. Okay, I'm showing you this. Just saying this website, that GitHub, I mean, it's the PARSEC World official GitHub for PARSEC, and there is also not plenty, but there are some other projects that are available for other papers and so on, so you can check it later. And in this link, we have put all the repositories for this session. So it's short. We tried a lot to make the shortest and could be runnable. What we have here is first the requirements that you have received on your emails with the information about downloading, if you don't have Jupyter Notebook set up, and created your Google Earth Engine, if you don't, okay? So everything is in this requirement. Besides that, we have this data set, which is the Setores Censitarios. Sorry, it's in Portuguese, Setores Censitarios Vale do Ribeira. And the other one is this one, Indicadores Vale Ribeira. CSV5. CSV5. So we have these two data sets, and probably it's better to show what they have. What else? This Python here contains a lot of libraries. This is not from ourselves, but we have made some updates. This belongs to the paper from G model that Ali has shown you. So this one contains many libraries to convert some templates and making plots. And I don't think the plots, but to making all of the stuff. So this particular code has plenty methods, functions, I mean, for making a lot of the stuffs. And we have two Python's Jupyter notebooks, which is one part showing part 1 and part 2. Part 1, we split it as only the showing which are the data set that we are trying to make this case study, and the second one is to get this information previous and then later to download it, the satellite images. After that, the next steps are to split this image and input as for the deep learning methods. But that is something that we will do mainly on this year, so you are going to have access in future, but anyhow, this is the way that you are going to download it, satellite images. Okay, good. So we are going to clone, and we need, so you can open your terminals and make, hopefully it's seen. Yeah, git clone, and you put the link. Oh yeah, if you don't know where to find this link, you can go here in encode on the website, and where is HTTPS, you have the link with the .git, so that you can clone everything from here. It's going to download it. So we are back to the terminal and clone this repository. Okay. Okay, so we are going to this. So I have cloned wherever it's here. And we open here. I don't know if I've shown the CSV file, or maybe on the, because I have it also on the Python. So we open it with whatever tool you are using, whatever editor, IDE, whatever you are using. Okay. Hopefully, another point is that since this code needed some plots using GeoPandas, so maybe you don't have this library. If you do, it's okay. And if you don't, you can create another environment and make the installation. We are going to need GeoPandas and the Google Earth Engine API. Install it. Okay, so we are going to wait for you, if you are doing now, if you have the GeoPandas. So. I think I have to change here my environment. I don't recall which one was the best. I think that this one. Yeah, I don't recall which one was. Okay, but anyhow. So I'm going to this one, and please text test. It should work. Yeah. So, okay, let's do. If anyone of you or in the YouTube session soon, whatever, please say us. So it's okay. It is. I don't know how to put in full screen this. Yeah. Yep. So everyone is there. Everybody has GeoPandas, has work. Okay, great. So here these libraries are special libraries for making plots. Some of them, I don't know if you are going to have this problem later, because GeoPanda has some conflict with another libraries. So if you have this problem by installing, for instance, the TensorFlow package with this GeoPanda, maybe you have some, no, it's not GeoPanda, it's the GDL, which is another library for a special analysis. So if you have this problem, you can create two environments just to run in one and the other one separately. If don't, great. Okay, so what is important from here is our data set. So we have these two data sets. They are available for you. What they contain is these two CSV. This one contains the shapey files from Vale do Ribeira. So it is now, I have treated previously this data set, but now it's with you. And this one reads as a data frame, okay, and it converts to the CRS, which is the, what's that? Yeah, the projections. So we are using this one, or you can use another one if you are know about these projections. Okay, so this one reads this shapey file. That's why you are going to see this WKT, which is the polygon of these shapey files.
Shapefile is the map of our study area.
You can take here also if you want. Yep. So this data frame contains, I think, 1,098 and 980 some. And this is this has come from IBG as well, okay? So you can also download it from IBG. This is open. The government gives this data set. And it contains the polygon, which is the coordinates geopolitical for these census tracts, the ID, and the type of these data sets. For instance, if it's urban or rural, so we have this information as well from districts, municipalities, mass sub-districts, and other information that you could also work so that you don't only use it as a census tract, but other granularities if you want. The name of the district, the name of the municipality, the name of the micro and the meso municipality, and this is all of what it contains. Okay. Okay. I don't know if I have run this. Okay. Okay, the next part is just reading, okay? Just reading these with some modifications of the names, so if we have some values, non-values, and whatever, and we are making some joining. Because we read it so far, yeah, no, only census, okay, census tracts. Okay, so we read this. And this is one of the nicest part, because how to download it, the images, it's by making the centroid for census tract. So this code, what it does, it reads the other, no, this one reads the, no, this one reads the Vale do Ribeira, different available, which one, let me check. Oh no, this one only reads the GPD, which is the GeoPandas. Okay, and this code, what it makes is calculated the centroid. So we have this function that calculates from the polygon, it returns you the latitude and longitude. I mean, the centroid from this polygon, which represents the latitude and longitude of this centroid. So we have this important information. Okay, so we run this. And so we added one column to our data set here, and we have now the center point and the latitude and longitude of these census tracts. The next is to, okay, well, I'm going to save this information on these BR clusters, okay. Yeah, this CSV file. I am adding 2 more columns because we are going to need for the next step, but it's only about which is this data set represents, which is the country from Brazil, and the year of the census, 2017. That's it. What else? I am missing, I think, another. Yeah, I think I'm missing the other CSV, but I'm not sure where it is. Yeah, the indicators. I don't. Some over. Yeah, it was here. Indicators. So what it reads is only the indicators, which are here. Okay. So this one again contains the code from the census tract. And here in this last column is the income, longevity, and literacy. This is what we have calculated, and it's also available in our GitHubs, okay, for Vale do Ribeira. Okay, let me move on. Okay, yeah, and we save this file. So in our, it's going to be saved somewhere here, so we have this, okay. If we open it, maybe we can open it here. Okay, this one, so it has saved the census tract, the code, Brazil, 2010, latitude and longitude from this one, the type, if it's urban or rural, and the income, longevity, and literacy. This is the shortest data set that we need for training our deep learning model. Because what it's going to do next is that it downloads an image from this census tract, and it goes directly to the training model. Yes. And it's going to train with this income. Okay.
And to download the satellite image, just you need the 3 information: the geographic coordinate and the year of images. Okay. To download satellite image for Google Earth Engine, you need to define the satellite sensor. For example, in our case, we will use Landsat. For Landsat, there are many products. It starts from 82 to now, and there are many products of Landsat. Landsat 4 to Landsat 8. Okay, there are some products in Landsat. And nightlight. Okay, so the aim of this step, with what Janet had presented now, is to prepare a CSV file containing the geographic coordinate and the year of that we download the satellite image. Also, here in this experimentation for Python, we will use the TF record format. As you know, TF record format is as a compressed table that you can put the satellite image, all the bands of the satellite image, also all parameters, the wealth index here, the year, all parameters in the same format. That will be useful in deep learning if you have all our information in the same file.
Great. So I'm closing this. I'm going back for our code. So let's try everything. This part, it's actually working. Okay, so these are the municipalities. We have this 30. These are the ones. Okay, and we are only here just making plots because it's very interesting to understand how the indicators or whatever other data, because you don't only have to think in income or socioeconomic index. You can think on healthy indicators, environmental indicators, and so on. So this is on the same strategy. So I'm going to make just some plots here. This gives you the understanding of how it's the centroid from each census tract. So, for instance, we have one census tract here, and this is the centroid from them. We also have census tract very small. So, for instance, this one is a very tiny, but we have it. Okay, and this is a municipality. Yeah, this one also shows you a plot distinguishing which of these census tracts are urban or rural. This is also good information because when we did the model from deep learning, we saw that the more highest the income, it corresponds to urban places, and lowest income corresponds to rural. So this was also a nice information to see. So this is the Valle de Ribeira, and we are seeing, which is in red, the urban census tracts, and what is in blue is the rural. Okay. And here it's the maps that I showed you on the slides, which is only to a color bar with the indicators that we have already. And this is the 3 indicators that we have. So it's taking a little bit. So here they are. So these values corresponds from 0 to 1, and the indicators. If you are seeing the ones that are in gray in here, it's because we don't have data for them, because the census tract, it's a rural, and maybe they don't have information, and the IBG don't make available the census for them for privacy. So we only have the ones that have at least, I don't know what's the number, but at least a good number of people that lives there, so that we can have a census from them. That's why they are in gray. For the other ones, we are seeing these other indicators. Okay, and this is the first part. So whatever is important here is that we have the clusters, which is the centroids from each of these census tracts. Okay. The second part, so we're going back to our GitHub, and we have the part 2. So we are going to download it, everything image from this CSV, and download it. So the first thing we need, if you don't have it yet, is the Earth Engine API. So for doing this, if you don't, let me see if I have it or not. Let's do it with the same. Oh, maybe I have to change the environment. No. Okay, let's see. Oh yeah, well, it ran. Okay. If you don't, try it with the other environment you tested before. So that if you have the problem, but let's see with my other environment here. So what is going to do this data set, this Jupyter notebook, is that you are going to download the image, and it's going to save you directly to your Drive. So everybody has to have a Gmail account with Drive. So let's try it. It should run. If not, okay, I don't have it. So I'm going to run the Earth Engine, I mean installing by using the pipe. Let's see if it's worked, because Ali told me that he has showed some conflicts with the GeoPandas with this, but let's see. So I am installed it here. Yeah, this one has. It works. Okay. This is another important part. This is the authentication. So Google has this Google Cloud platform with a lot of services, just like the way that Amazon AWS also does. So they have this cloud, and they provide you not only Google Earth Engine, but they also provide you with Google Street View and plenty other services. So we make an authentication. What is going to directly to a website, so it's going to take you here. And this has changed very recently because when we ran this 2 years ago or so, it has changed. So the authentication has changed. So if you are here, you go for, okay, if you want to switch your account, your Google account, if you have a project from a cloud project, you can put it or just leave it as the default, okay? And we generated token. What we are doing now is only making the security access, so Google creates a validation session. So I'm going to choose my account that I have already created, the Google Earth Engine. Everybody, it's until here. Okay. Okay. So let's see, I'm going to continue. So this part has changed because the API asks you for these two things, and when I put here continue, this has changed. But it's okay, now it's the way that Google has made it now. So, and what is important here, you copy here, okay, the token, okay, which is a one session only, so when you are finishing or whatever, it takes a session, a short session, I don't know what time, but if you are, I don't know, it's the session closed, you have to, again, create a token, okay? We are just waiting here.
Just here for the Google Earth Engine, as Janet said, is as cloud for satellite image, and there are many API to use the Google Earth Engine. So you can download the satellite image, but also you can just extract some information what you need. For example, as for the NDVI, just for a selected pixel, just you can extract. And I think now there are many open source tools that you can use to manage with information in the Google Earth Engine, like Learn, for example, and many other open source for each sensor, as the Sentinel-1 and Sentinel-2.
So, okay, I'm copy that token and going back to my code. So here is waiting. So I'm putting here. If you are working in Jupyter, whatever other IDE, for instance, Google Colab, it's going to wait you from here. If you are working on this, what's the name of this? The Visual Studio Code, it's going to wait you from here. So I'm going to put the token and enter. And it's going to say you successfully saved authorization token. You are here? Yep, okay, wonderful. And after that, we do now the initialization with the Earth Engine API. Okay. This takes a little bit. Okay. Next. We are only making which are going to be the names for the folders that you are going to download it on your drive. So this is the parameter Google Drive. And here is the name of your folder. So you can change the name. For instance, I'm going to change like, no, but it's not going to work. Yeah, whatever name you want, okay? Okay, you can change here. This is going to download it the whatever other folder you want. Okay. And this part, okay, reads the previous CSV that we generated before, and some parameters, for instance, the multispectral bands, because we are working on downloading two kinds of imagery, the night lights and the multispectral. So here I only have the parameters for the multispectral. Parameters, for instance, the projection that you are going to work, the scale of this kind of imagery, and the radius. Maybe you can talk more of this, Ali, if you want. Way to run this. About the values.
Okay. Here just the scale of the spatial resolution that we used, and some information about the system of projection of the satellite image, and because there are many projection system, and here that's the name of the bands. As you said, for Landsat we will use the seven bands, and here and going okay. Here the ID is from the CSV file. It make a group by when you have okay, in the case of Val di Ribeira we just have one country, but just one country. But here this step is to consist to make a group by country and by year, okay, to download the Landsat and nightlight images. In this case, just we have one country and one year. In the output, it will be just one image.
Yeah, so this part is waiting for these two columns that we named before, which is the country, which is Brazil, okay, and the year. So the hours, and yeah, only 1 year, 2010. But you can download other years, so you only have to change the CSV file and add it other information. If the Landsat has this year, because maybe it doesn't have, okay. You have to check the availability. So we run this. And this part only makes the tasks, so it waits for many tasks to go to the Earth engine. So you can take many tasks. You can put it. It's like a tuple, okay. And here, it's going to. What does this here? Yeah. Only that runs the task, okay. So you are putting here this folder. So it's only to create this folder, and we are going to run this. And this is what is running actually for this chunk of.
To check the status of the download images.
Yep. Oh, this is something nice. We have going for the Google Earth NGI. What is? Yes. Okay. I'm going here. Okay. I'm going to run it, and it's going to download it. It's only 1 gigabyte, so kind of 1 gigabyte. If we go back here, what is very nice also, it's which does say Google Cloud platform. Do you have the link? In the requirements.
The link of.
Yeah. Mm-hmm. Okay. So if you go here in the requirements, if you don't have it, we open here. This one? No. Which one? Yeah. No, I have it. Okay, this is the platform that you maybe know. This the Google Earth Engine. You can work also with JavaScript, and you can go here, which is the inspector, the console, and the tasks. So these tasks is what is being collated with the Python. Okay, I have tested this many times, so that's why you are seeing many tentatives. So it's here, and you are going to see, if you have plenty downloading, you are going to see each of these tasks being downloading here. Okay, so for instance, this one has, I think, has downloaded now. No, yeah, it's done. Okay, so no, it's not. It's still waiting. No, it's completed. Okay. So we are seeing these tasks if you want, and you are going to your drive. So for instance, my drive here, it was the same one. And if you are looking for where that's downloaded, I'm going to refresh. And this is, okay, the folder that I have created. And here it's this TensorFlow TF records that has downloaded. It's not what's in gigabytes. It was very short. Yeah. No, it's not.
For
it's
1,000.
Not. Yeah.
1,000 megabytes.
Yeah. Okay.
But here there are some parameter of the Google Earth Engine. Just you can download at maximum 3,000 images in the same time, and there are some also for the size. It should be, I think, I missed the information about the size. The size of maximum is, it will be, I think, 15 giga in the same in the same in the same time, yeah, in the same time, yeah.
After that, the next step is to show the which is corresponds to this this downloading, but that's something that we couldn't work. So we are going to lend you this. If you are going on our GitHub, it's going to be here a part 3, which contains where it is. Which contain how to look these images. So from our presentation yesterday, for instance, what you are going to see is that after you download this image, you are going to have this Landsat, okay? If this which corresponds to the bands. Okay, blue, green, red, and the other ones. That is the third step, and it contains an imagery that is cut, which is 224 pixels by 224, and this one actually is entered to the deep learning model, and it goes after with the ResNet model, and that's it. So hopefully you have enjoy this presentation. Thank you.
But if you are interested to finish all the pipeline, can you ask me or Jeanette by email? And you have all the pipeline, and I think that will be shared as soon as possible, all the steps with the deep learning
and also with the deep learning model. Yeah. Where is this finished? Yeah. Yep, here. So another point interesting is for our students, or whatever students that may have interest in working, if they have future projects, you can contact us for collaborations, and so that's it. Thank you.
Hello? Okay. Okay. Can we start? And I had an announcement for the students and for others. We will have 15 to 20 minutes of talking about the field trip we will have at the weekend. So it's not related to you. You are, of course, welcome to stay and listen. And then after that, the presentations will follow, okay? And so I just want to tell you some information about the park. And I think this information is important for you. And so this is the place where we are going to, Parque Estadual Intervales. It says Intervales State Park. It's one of the best state parks in the Atlantic Forest in São Paulo state. So we say that we go to the heart of the Atlantic Forest, and it's true. So it's good for you to know that you have an immersive experience in the best portion of in more pristine Atlantic Forest in the whole biome. And we will stay here. Pousada Lontra, and a restaurant, and other accommodations and lodges. They are all in the middle of the forest. And, oh, thank you. Yeah. And I think it's very good for the PARSEC contest to be aware that this journal started here in the van at the University of São Paulo. So we planned and decided by the Intervales State Park because it's very, very close to the, oops, wow. Okay. It's actually this park is not inside the Vale do Ribeira, but it's close to. The Vale do Ribeira is this portion here, and the municipality of the park is here. So, yeah. I'm trembling, but yeah, yes, here. So, São Paulo and the Intervales, so you will travel by a big road until Sorocaba, it's a big city, and then from Sorocaba to Itapetininga. And from here, you will face a very many differences in the landscape, but also in the socioeconomic context of the local community. So it's very important for you to realize that you are moving from the top of the state in terms of urbanization and education and socioeconomic aspects go to here. And this park is located in the Atlantic Forest block, or continuum, as we call. And okay. And this is what remained from the Atlantic Forest due to deforestation. So this continuum harbor many protected areas. So this is the Intervales where we are going to, but the Intervales is linked to other fully protected areas in the Atlantic Forest. And this is why this portion of the Atlantic Forest is preserved and it was not deforested. And also the mosaic of the protected area allows species as jaguar, for example, live here. And this is the only portion in the Atlantic Forest in the state of São Paulo where you can find a healthy and good population of jaguar, for example, a highly critically endangered species in the biome. Yeah, so the accommodations we are going to stay are these lodges, and they are very simple. And the room in the very simple but very clean, and no internet access in the park, so be aware that no connections. And but the place is very, very nice, very good place to stay. We will have meals inside of the park, so a local restaurant, a local person that lives in the community surrounding the park, works in the park, and she will offer the meals. So not so many options, so very, very simple but good meals, very different from the meals you were tasting this week. But and she knows about our specialties and necessities in terms of gluten and milk and a vegan, and so she will be prepared. And what to bring? So Janet just sent this to you. So just be sure that you have all these things. If you don't, just let me know, and I can try to arrange some things. And what is very important is, good shoes for hiking, because we are planning to go for some trails, also for some caves, but not wet caves. So, and also for some one waterfall. And so long pants, because there are lots of snakes, and this is an example of the trail, so they are very clean. But of course, we will be in the middle of the forest, so we should be to keep in the trail and avoid to enter in the forest, but wear, of course, proper clothes and a hat, because a sunny day is going to happen. And a bottle of water, backpack, sunscreen, repellent, and the accommodation doesn't have this type of things, but they have towel and sheets. Yeah, thank you. And the fruits and the snacks Pedro will provide for us, and alcohol is prohibited. So yes, it's by state law, so avoid risks, and in the park it's not allowed. So. Oh yeah, I just included it here. Yes, and I just put here, I will share this presentation with you, so probably we will have a very sunny day on Saturday, not so sunny day on Sunday, but it would be nice to see the difference in the 24th. And so you have to leave at 2 p.m. and to avoid the dark, driving during the dark or during the night, just to have a safer trip. And we are planning to leave the park at 11 to avoid problems with the airport. And we need to pay attention about the hours, so it's good. Everybody knows that for us to avoid the delays. And I would like to know, because I will be in the park waiting for you, but I will be out of connection. And so I need to know what time you leave from São Paulo, just for me to be in front of the entrance waiting for you. And just let me know when you leave from São Paulo and when you were close or in Capão Bonito, so it's a city, you will see this or ask for the driver, because after Capão Bonito you lose the connection also, the internet connection, cellular doesn't work, so in most part of the road. Janet will have a copy of entrance tickets. I will be there, but just in case, as a backup, so she will have a copy of your ticket, because I already bought the ticket for you, so it's already done. And Pedro is paying for ticket, accommodation, and meals, so you don't need to worry about this. Everything is okay. Actually, FAPESP is paying maybe no, or Pedro and FAPESP. And don't drink water in the park, because if you are not used to, you will face problems with, problems here. So I don't know how to explain this, but I know you understand me. So Pedro will buy fruits, snacks, and water for all of us. and no internet, and just let me know if you need something, if you forget something, if you need something, if you have any doubts. I will be there with my car, so the van will not stay with with us there, right, Pedro? But I will be with a car, so if we need an emergency, I can drive to the city, and so don't worry about this. And I think that's it. So all that I have by now, and I'm not sure if you have any doubts, or just pay attention when you were in the van and to look the transformation of the landscape. And I think this is a very nice experience for you to realize that the local communities close to these fully protected areas in Brazil, they don't have, and they don't receive any benefit from the protected areas. So the protected areas in Brazil, the fully protected area that corresponds to IUCN 1, 2, and 3 categories, they are kind of a fortress conservation. So no people and no benefits for people that lives close to. So communities that live close to the protected areas in Brazil, they don't like protected areas, of course, because they don't see any advantages. They only see disadvantages. And this park has a very nice and huge infrastructure for tourism. You will see this. And, but this type of tourism is for people like us that can pay for it. And that the people that live in the cities. And then it's not for the local communities. So, and this is important because it's part of the context of our discussions, the impacts of protected areas and on socioeconomic aspects. And yeah. So I think that's it. Yeah. Any doubt, any question, or I really hope you enjoy it. And yeah, so that's it. Thank you.
This one works in case. So we'll move on with Margaret for your second talk. I'll give you mine. So it's all yours.
Are we recording? Should I? Oh, there he is. Am I okay? Okay. Hello? I am. Okay, now where did we leave off? Okay, so this is kind of the second half, and in some ways this is a continuation of what I was talking about this morning. But basically the title of this section is The Value of Controlled Vocabularies for Research Data. So basically this little rehash here, the basic goal of a research data repository is to publish and archive data from research projects. These are pretty diverse. Almost any kind of research can be archived, at least the data can be archived somewhere. And we want to make sure that that data is available for future use. So over here, that's the kind of landing page you would see for every data set that appears in a repository. And we want to make sure that the data are curated to the most complete level possible and that they're easy to find. And that's where controlled vocabularies come in. Oh, this topic came up during the break, and so I threw in one more slide. I think it was Alan who asked me, how do you decide how to use repository? There you are. How do you decide how to use repository? So I started going through this list of features, and I thought, well, gosh, I should just put these somewhere. We can come back to this if you like and talk about it some more. But basically, you have a couple different choices. You can look for a DOI is essential for either a data repository that you would consider just adequate should be able to do that. Because with a DOI, if you're able to mint a DOI, then your you're taking on a level of responsibility for permanence that isn't there with a simple website. Because if you've registered a DOI, that means it's a permanent identifier. And if the repository goes down, it should have a plan for how that material that's close to those DOIs is transferred to somebody else. Revision control is pretty important too, because almost every data set or metadata record probably will need some sort of maintenance, like an email change or something. A name could be misspelled, lots of things will happen. If you're in the best repositories will have a lot of other features, an API so that you can pull data sets by computer. You don't have to go visit a website, download, or ask permission. Should have measurement level metadata, so not just the people, the locations, a title. Those are pretty high level metadata elements, but they don't tell you exactly what was measured. Some sort of data validation. This could be either structural or depending on the degree of specificity of the domain that this repository is associated with, they may have some kind of evaluation that's more scientific. Ideally, it's going to contribute to a larger network, so that would mean your data then could show up someplace like the OASIS aggregator or Data One, or we'll see in a minute, other places. And other sorts of data exploration tools. These could be specific to the kinds of repository that it is, or they could be general. Okay, so we can talk about that some more because maybe there'll be more questions. So this is a plot that I had in the other talk. And in my opinion, the ones in the middle provide those services. The ones down here don't have measurement metadata, and very often they don't have any services to go along with those data sets, but these in the center do. The ones up here are highly specific to particular kinds of data, so they may or may not be appropriate for what you have. Okay, so now we're going to talk about control vocabularies. So when you go to look for a movie, you don't usually have to sort through a dozen Spider-Mans to find the one you want. Somehow, the search engine knows which one is the one that's the most recent, and you can kind of, if you want to look for the others, you can hunt. But when you're looking for data, very often that's what you end up with. You end up with like all the Spider-Mans, and now which one is the one I really should be using? How do they figure that out? They figured that out. Well, and as a researcher, you might say like, oh man, I know there's an LTER site near Santa Barbara, and they have data. How do I find it? Well, it turns out that Google can find it also. And that's like one of the most exciting things to happen in the last few years. And it's happening for the same reason that a major search engine can find the most recent Spider-Man movie, or they can tell you the menu or the hours of your restaurant when you first go look. At the top of the page, you see all these little mini links underneath business. It's because they're using something called schema.org. And schema.org is a standard vocabulary for marking up website content. It's commonly used by businesses, and it's been recognized was developed by search engines. And they now, in the last couple of years, have started a data set search. And that's the link to it right there. It's not one of the, when you go to Google and there's all those little buttons at the top where you can go everything, images, shopping, restaurants, shoes. There isn't one for data yet, but there will be, and that's when we can stop. But anyway, right now you go to datasetsearch.research.google.com, or just Google dataset search, and you'll find it. And this is the kind of search you will get. I just put in Amazon rainforest, and I got, I don't know, a few hundred data sets popped up. So that's one of the ways. This is the URL right here. But you can, if you just, in your Google search engine, just type dataset search, that'll be the top thing that you hit. Okay? So how do repositories use vocabularies too? One of the main things, or one of the first things they will use them for, is to help your searches, to speed up your searches. At EDI, we use a controlled vocabulary that's, it's a fairly simple one that has parent-child relationships. wait a minute, I have to back up 1 second. Who here has worked with vocabularies or ontology or RDF? I can imagine a few people. Or graphs. You use graphs in machine learning. Okay, but, okay. And that true for, do we have online people still? Some? Okay. And are they students? Are they in You don't know, okay. Okay, so they use them for creating catalogs is the main thing. And you can use simple or complex. But this is a kind of, just like I put the repositories on a spectrum, you can put vocabularies on a spectrum as well. And based on their complexity, back up. Based on their complexity, you get additional power. So down here, you would have things that are just simple lists. It could be, which you can't read, a glossary. This, for those of you who work in biodiversity, Katya, you've probably seen the essential biodiversity variables. It's just a list of terms. They haven't done a lot with it yet, and we would really like to see that move along. Then you can move up the spectrum a little bit and see Darwin core terms or things like the CF standard names. If you work in atmospheric sciences, you'll be familiar with those. The British Oceanographic Data Center has a pretty good thesaurus. If you can see the dots, you'll see that now there's connections between these trees that weren't here before. So that's what you get when you start to add additional power. And then at the end, you get these things we call ontologies. And that's where the real magic can happen, because you can form pretty complex relationships between concepts that are both human understandable and machine understandable. So most of the time, like with the Spider-Man plot, most of the time when you look for data, it's gonna look like that. And you're gonna go, I have to find some red and white t-shirt, is that what I'm looking for? But if you when you start to put in plain terms, like if you said red and white, you'd probably end up with that cabana and the umbrella and this guy in a shirt and a towel and a boat. But none of those are Waldo, so you know you haven't hit your thing yet. So, sorry? You don't know how, don't you have Waldo? You do have Waldo, okay, okay. What did you call him, Waldo, or does he have a different name here? Wally. Oh, I have heard Wally. Okay, so this is Aware's Wally. He's straight out of the book. He's in there. We'll find him. So what you really need to be able to do is ask the kind of question like, I'm looking for a person in a t-shirt with red and white horizontal stripes. And if you can ask that kind of a question, look, I only found 2. And you know what, there's Wally, he's right there. And this other guy. But with only 2, it's pretty easy to spot the one that you were after. And they both have the right t-shirt on. So that has pretty good recall and precision, I think, because I don't think there's any other red and white shirts in there. So if you're thinking about data and the concepts of fair, if you have a pretty simple vocabulary like this one that the LTER uses, you can help with the F in findable, because you can use that to create simple catalogs that will help narrow the field, and they'll look for things like synonyms when you're searching. But if you really want to enable interoperability and reusability, you need to have these more complex relationships that show up in ontologies. So this is great. So most of you don't work with ontologies, so you don't know what these are. So basically, ontology is a mechanism to represent knowledge that's readable by both humans and by machines. The basic unit is an RDF graph over here. It's basically a sentence that you're creating with a subject, two things that are linked by this verb, basically, the statement in the center. And then you make, from these RDF linkages, you can create a graph where a whole group of these, of a whole collection of RDF data is linked together. So you can get, oops, it ran off the edge. You can create these enormous, they can get actually quite large, networks of things, where this one is something about how Bob and Alice visited the Eiffel Tower in Paris, and they went to the Louvre and saw the Mona Lisa. And I'm not quite sure why Bob is connected to the Mona Lisa, but there he is. But now we're over here, off the slide, we're over here in this very highest category. We're in linked data now. So what does this look like in these sentences in real life? So I took a person that we all know, and I turned her into a sentence. So the sentence here is Shelley Stoll is a person. That's one of these relationships here. And if I was going to put this in a computer, though, if I was going to put this in a computer, I wouldn't use her name, and I wouldn't use this English word is a person. I would use her identifier. So remember how we've been hearing all this about orchids? That's what the computer does with it. It doesn't just, that's all the magic, everything that's going on behind the scenes when you put an orchid in there and it hooks up to Data Cite and Crossref and everything that happens. It's because they're creating this thing and they know Shelley's a person. And we're using an identifier for a schema.org person. And yes, I always find it amazing that a simple thing like ISA turns into this big long ID, but there it is. And here's another one, another kind of a relationship. Shelley also happens to be a member of AGU. So I used her ID again, and here's another ID, and then this is the identifier for AGU as an organization. So these networks, these can all be linked together in some large thing like this, where all the people in AGU could fall into this little nest, and they can all be linked with their sentences. What else am I missing? Okay, these identifiers, these are actually really important. They're not just random strings that you might make up, say if you're creating a table and you have a column that's the row number. It could change. You add a line of data and the row numbers will all change. These are what are called IRIs in English. It's an international resource identifier. And like a DOI, they should be persistent. And Leslie alluded to this morning when she was talking about responsibility for terms that are used in vocabularies, that there's a lot of discussion that has to happen about how vocabularies are made and how these terms are generated and who takes responsibility for them. So they're kind of a serious business, but it's important that they are recognized. So because we don't want, Shelley can't change her ORCID now, ever. Because once we nail it to something, it would be confusing. And so we also want to be able to trust this as a relationship, and that schema.org is going to continue to call people persons. And I can show you this because you're computer people. I could not show this to ecologists, they would leave the room. That's what all that information, when you stuff it in a data set, it would look something like this. Well, it might not look exactly like that because it's going to depend on the metadata, but it's structured metadata, and so you could transform that into this little bit of RDF, and that's got all the stuff that someone like Crossref or whoever would need to make the sentence about Shelley's papers. So this is an ontology that we love. It's called the environment ontology. It's terms for describing data. It has fairly well-developed trees for places like for biomes, for environmental materials. It imports other ontologies for chemical substances. It's quite useful, and we've started to use this a lot in almost anyone who works with environmental data is starting to use ENVO is what we don't call it. We don't say the big long name. We call it ENVO. And so basically, it has these kinds of sentences written out in that RDF framework that I showed you, where you can say, I'll read this to you because you probably can't read it. So this is ENVO's representation of an oasis. Whoops, sorry. An oasis has a part that's a spring. It's a desert oasis, which is part of a desert, which is a vegetated area, and partially surrounded by sand, rock, or soil, and it has this condition arid. So with these kinds of descriptions, and here's another one, so here's a volcanic eruption process. So it involves planetary crust, it has a participant, a volcano, the input is magma, I love that part. And here's the outputs: hydrogen sulfide, carbon dioxide, carbon monoxide, water vapor. And all of these are chemical substances. So they actually are described in an ontology that ENVO has imported. And that's where that's why we need, whoops. Where did it go? I thought my next slide was, I skipped to it. That's why these are actually, this is not for the faint of heart. It's not the same thing as making a list of terms and putting definitions on them. You need to be computer scientists to be able to do ontology, and that isn't me. I'm this person in the middle here, the repository. I kind of understand what they're doing, and if I spend enough time at it, I can get okay at the editors, but I usually need a professional to tell me where I messed up. And that's this person sitting over here looking at RDF. But it's really useful. We don't expect researchers to know how to do that. Researchers actually need other kinds of information professionals in the middle to help, because we need their expertise, but we don't expect them to understand all the underlying stuff. So what I skipped over, this is a poster that Roman put together about a year ago for RDA, and it's basically how a community gets together and constructs a vocabulary. This could be any kind of a vocabulary, but in his case, I mean, even if you were making a set of terms, and I'm sure that GeoBond went through some kind of a process like this when they did the biodiversity observation, or excuse me, the essential biodiversity variables, because they had to agree on the terms, they had to agree on definitions, what's important about them, what are their qualities. And then down here he has this enormous, well, it's not quite as big as it should be, stop. Because right there it says, go look and see what other vocabularies exist, and if they're reputable, use them. That's what this whole thing is right there, before you finish. I think it actually should happen up here, but we'll talk about that. Did this, and so now once you're tagged, so what we can do is we can take those RDF, our structured metadata, we can add these URIs to it, and now we can have data sets where you can actually and then enable this 4th star level of data quality. So you can actually search by ontological terms. Where we are now is that we need more data sets that are tagged this way. For the last decade or so, our biggest hurdle has been getting data sets in at all with good metadata, and now we want to add this on. And one of the questions I usually get, I'm going to ask it right now because someone will bring it up, is if you have all these data sets with metadata, can't we use machine learning to attach these terms? And it's complicated, so we should talk about that. You should be able to, yes, but it's been tried, and in a lot of cases, the metadata is not as a high enough quality. It's okay, but when you have something that's very generic, like think of a paper abstract, and it will have lots of terms that go into lots of ontologies, and trying to decide which parts of it belong in, it's complicated, belong in the chemistry, which belong in the ENVO ontology, it's pretty tricky to suss out. And so, yeah, we need help. Let's see, where are we? So where is EDI? So I showed you this plot earlier, but I kind of stopped here. EDI, we arose right here around 2014, 2015. We are making schema.org, but we're only using the core vocabularies. In the schema.org world, there are actually people who we know in the repository world who are working on extensions to schema.org that are for data sets and measurements. And that will, when that comes out, we'll be using that, I'm sure. We also there's other ways that we can get ontology into our data sets other than schema.org by using things like ENVO. We're still looking, what we're trying to do now is build a corpus of what you would call training data sets. So if experts assign terms, then maybe that'll help a machine learning project do the rest of the data sets that we have. And we're back to this again. So that's it.
So, would you have any questions for Margaret? You're welcome. Here or maybe online. Please.
Thank you for an excellent presentation. I enjoyed a lot. My doubt is, how should we pay? Should we pay for a DOI registration and for a repository? Oh,
there's no charge. Well, there is no charge now. It kind of depends on the funders, and for the moment, the repositories are still relatively new, and I don't think they should ever charge, but they don't ask me. I think that funders would like to find a way to peel off the cost of repositories somehow, but we haven't come up with a good model yet, and charging researchers isn't it. It'll just step on their grants again anyway, so what's the point? But they're, like I said, they don't ask me. Sometimes they do. So yeah, there's no charge.
Thank you.
Oh, but one more thing. But repositories do actually pay for DOI registration. Actually, there is an administrative fee. So it's nominal. It's part of our operating costs, though.
Any other question or comment? No? Okay, then we are moving on for the last part of the day. So with a session on the reproducibility of PARSEC experiments. And if I understand quite well, it's going to be in 3 parts. So to start with, we'll have Professor Pedro for a demonstration, software demonstration. That's all right. And then we'll have a session on the dataset compatibility. I think that will be with Jesse, Joe, and Alec. And to end, session on the reproducibility of deep learning experiments. So to start with, software demonstration.
Could we start? Yes. So, thank you everyone for staying here until this time. This is I think it will be the last presentation. Maybe there is one more. I hope you are not so tired. So I will talking about what we have done about the reproducibility, what we have done about the data management related with technical side, related with what you are preserving the data, because we are talking about a lot of this during the day, and we must understand what you are doing, what kind of tools we are using for develop the experiments, because I think the PARSEC should be the reference for others' reproducibility project, like, you know. So this is what you are trying to do. So during the PARSEC project, we work here, mostly here at University of São Paulo, but interact with Margaret, interact with Shelley about Alison, about what should be the nice infrastructure to manage this data, to develop an experiment of data science. And the idea is you must record everything in every stage that you are doing to promote the reproducibility, because this is one very important question that we are doing during the project. So we have this we kind of tool, data map. So data map is a platform that you are working here. There is many people working here. André, Caio, Wesley is not here. Felipe, Márcio, where's Márcio? Márcio not here. And Ricardo Martinelli. We have a lot of people working this. So, during the PARSEC, we developed a DOMP. Everyone knows. On Monday, someone of you, maybe you don't know what is DOMP, but now everyone knows, okay? So everyone knows what we are talking about this. And in DOMP, we have some recommendation because we are acquiring data set of different sources. For example, from Brazil, you are acquiring data set for IBGE, you are acquiring data set from images. You are put all together, but you must record, register information about them. For example, what are the DOI, what is our metadata related with this data set. So this is one big, huge problem. In DOMP, we recommended to, let's create a data sheet. I remember when we started the project, Alison was the author, I remember. But let's use this data set, because when you acquire, when you make some acquire one data set, you want to register about this. So we created a spreadsheet for this. But we try to be very disciplinary. All the time that you acquire images, you must register all information. But we forgot sometimes. Yeah, this was a problem. But this data sheet is very important because when you are going to publish, you know. And because we are working with data from different countries. For example, now in Japan, you are accessing some images that maybe you don't have access, and Conde is providing for us. Now you are working with people from Australia. They are deliver data, but you must register. When you acquire the data, you must register what you are learning, because when you start to experiment of data science, the first thing that you do is make a data exploring. You do descriptive statistic analysis. You do when you start to work with this data. So you must register what you are learning when you start to work with the data set. So you must automate this stage, because if you don't automate it, okay, you have directions, you have towards, but if you don't have tools, forget it. People they don't use like we try to do. So. But it's important because we define what you need, all the data you need. So we develop a tool for managing this. This is what you have done. So we call the metadata, the rules. So this is the idea. And when we must record, for example, how the software to acquire this data, because we have the APIs. Sometimes it seems to be simple, but try to use the Google image, the access to the satellite image is not so easy. Jeanette spent 2 or 2 months for learn. Yeah, 1 month at least, I remember. We don't know how to access. So when you are writing your scripts, you learn, but you must register this. You must automate it, to acquire automatically. This is the idea that we should have a tool to provide this during the project, the data map. So the data map, during the project, for managing all information, we use a lot of tools for integrated people, for managed software. For example, for managed software, we use GitHub. For managed, we start with Slack, but we try to use so much Google Drive. All of them you can access using OSF, Open Science framework. I think some of you knows this, but it's very nice. Because here you can access, we integrated all, you can access in the same place, in a portal. The idea of the portal, you can access a lot of information. You can access the Trello, you can access the GitHub, you can access Google Drive, you can access a Node too. For example, you can see your publications. You can access, for example, Mendeley, for example, all reference that you are using for write papers, everything. And we can access all our data set that you are using, because thinking about this, we have worked with different countries. People that are from different countries, they must trust you because we are delivering our data for people analyzing. For example, Kondo is delivering data for us, for Janette, for Ali, to analyze the data. But Kondo must know what data they are delivering. So, independent of the profile of people, everyone of the project must know all data set that is available and what's happening with that data set. So this is because we must be transparent. I learned with a lot of this with Alison during this last week. We must be for trust in the analysis for all team, mainly in all team. So we in OSF, for example, you can access all the data that is available in our infrastructure for aggregated. We call data lake. All data set that you are acquiring for experiments here. And we use Jupyter Notebook, of course. You see, for the experiment, you use Jupyter Notebook. Jupyter Notebook has integrated with OSF too, because it's interesting. We can see the code. And so, but there is a gap between because all metadata, for example, we don't access the all metadata that when you acquire the data set, for example. Some of them, there's not so much integrated. So we are using, we created some tools that facilitated, that integrate the access for this data lake, for example, and facilitate some data exploring, automated this exploring, facilitated the automation for integrating the data that you are bring from the different data sources. So we call data map, but data map has some very interesting. We use all the recommendations, APIs, for example, here. We can access, for example, all that we are doing here by APIs. And this is our platform that we are using. I will show more information about this. But we start in Data Dictionary. It was very nice to talk after Margaret, because I'm talking about how you can automate many of the things that Margaret told us during her presentation. So, yeah, we start here. But our idea that we can work with data analysis for example, we can develop some experiments, not all experiment, but the idea that we can make data exploring, for example. When you get your data set, you must do some data exploring, understand what you have in the data set. So you have some models for here. We have some models for data visualization, for example, for you see in the maps what you are doing or your data, because you must see your data. So we are developing this, and we have some possibility to connect with using ORCID, your ORCID, okay? So you are using the APIs of ORCID for access all this environment here. But now we are just working this, but we must have some architecture reference to start this. Oh, what you use as a reference? When you, for example, we start to study the catalog of Google Dataset Search. Google Dataset Search was launched in 2019. I remember I was in EDU. I saw the advertisement of people of Google. I was in EDU, thanks to Shelley, EDU 100, 2018, in Washington, D.C. 19. Before the COVID, yeah, 19, yeah. I remember it was the first time that I saw this, let's study better then. So we start to study this, and I used to slide in a lot of my courses in the data science course because I would like to show to students how they can publish their data. Because if you have a website, for example, I'd like to publish my data. So, and would like the data set could be visible in Google Dataset. So I explained, do you remember this? I don't know. You remember this slide? Yeah. So the idea is we extract metadata automatically of the data set that you're acquiring. So we put this in our relational database, Postgres, and index it, and we can search. This is simple. This is this is the same thing that Google Search is doing. We are doing the same. And yeah, if you want to know better, there is a paper published related with this. This is the guys that developed this. I think some of them, they work with California University. Yeah, maybe they are, yeah. I know because I remember when they are developing this solution, they travel a lot. I think they were at the Oak Ridge National Laboratory to ask about this, some solution. I remember that yeah, I know. I remember Gear comment something like this. So, how you manage the data? We use schema.org. I didn't talk with you, sorry. Sorry, Margaret. I did sorry, but I am, again, people, we are using schema.org, and there is a data set that describe all mandatory and some vocabulary that you can use here. And there is very, very interesting material. If you want to go, you can go here, and you will have a lot of information about how you can document your data set. The idea is to use API. The idea to use API because everything that you are doing here is available by API. And you just develop your application. Your application could be running your iPhone, or running your computer, so you can access everything by API. But of course, we have some application. We are going to show this application, part of this, that is there is a front end. This is the first time that you are going to show, I think. This is, no, second time. We have a second presentation of this. This is we just finished this, sorry. Maybe we have we tried. I hope everything works. Yeah, and we are using API here, and there JavaScript, everything in the front end, or just to understand, all the application that you have is right in running in your computer JavaScript, and in the back end you use Python with the Django. It's an environment to run Python. We have a diagram class. I know talking about this, but yeah, this is the information about what you have about the code and about the database. But it's interesting that we are working. We are using single sign-on because our reference is ORCID, but we use the OSF account because I think OSF is a nice hub for everyone, for every project of data science. People log in there, and I can access a lot of information of the project. Reference, the experiments, everything. The data lake, you can access there if you want. So there is different, we can deploy this in different front ends, your mobile phone too. The idea is that we can pre-processing the data set. For example, when we acquire, for our students are acquiring the data they have, we don't need to do it because we are going to automate everything that could be necessary to maintain our data in our data lake. Because the data that is in data lake is the data that we select to our experiment, in our data lake, of course. There is some features for visualization, mostly maps, because you use a lot of maps in your experiment. And one thing that is most important that we must, in our case, multi-language, because we are working the project that involved many countries, not just English. So we are working with this capability. So we have a short, where is, let's go? Yeah, please.
Okay. I'm sharing the screen via Zoom. Can you show it in the projector, please? Hey, I'm sharing the screen via Zoom. Can you show it in the projector, please? Okay, so let me start first. I'm Caio, one of the students that is advised by Professor Pedro here in doing a master's degree, and I'm involved in data map also. As of today, I'll show you a very quick sneak peek on a very preliminary and incipient work that we are doing to get a taste of what Professor Pedro was talking about, of what is data map and what we are doing to achieve that data dictionary modulus that he talked about. So one of the feedbacks that we have from our researchers in our group of research here in Brazil is that it was very difficult to find the data and to have a centralized space where we can get multiple different types of data. So that's why we are starting by the data dictionary and data discovery to deliver something in small chunks and to deliver value faster than trying to develop all the platform and then delivering to the researchers. So if you guys have used Kaggle before, this is very inspired by Kaggle, the layout, the design. This is something that you guys can access on your notebooks. But until now, we have just mocked data. In the next weeks, we would have much more information for you guys to show. So this is the homepage. It has nothing yet, but the thing that it's actually, let me show you something first. Okay, let me just sign out. So as Professor Pedro said, we are working with single sign-on, starting with ORCID. This is the most preferably way to use this tool. So you can just log in and then link your ORCID to our data map tool. And after that, you can search the data sets that you want, that we already have here in Brazil. Some of them, if you try to search here, these are actually real data sets that we used in some of the presentations that we have before. For example, as Marcio presented or other people here. But you can search for metadata, you can search for some strings in the description. This is a full text search. We also will have some categories for the data sets. some level of information, or some data type. We are heavily inspired by the FAIR guiding principles. So by making this, we are trying to make the data searchable or findable, as in F from FAIR. And let me just show you here. So let's just get this merge. You can search here, as I said, as a full text search, so you don't have to have the specific name of the data set. And if you access this, okay, this is the mock-up data that I said. I will work on showing the actual data here. But here we will have the details of the data set with a markdown type of file, so you can type code here, or you can type any kind of thing that works with the markdown format. And you can search for the metadata also. And I said before, not just the metadata of the data set, but the measurement data, metadata also. You can get citations, you can assign DOIs for the data sets that we have here. And in the future, as a new feature that we are looking for, you could not just download the data, but we also can transport the data from the cold storage that we have to a specific isolated environment for you to execute and explore your data using Jupyter notebooks in the cloud. So, as I said, this is heavily inspired by Kaggle. You can do also this in Kaggle, but they do not have this research methodology, as Professor Pedro was talking about, and all the integrations that we are looking for implementing here. Some other things that are nice to say is that we are also working on have some usability scores for the data sets, on plotting samples of the data sets in charts for you to explore it without having to actually set up everything else, so you can find your data more easily. I guess that's it. If you have any questions.
Thank you very much. Actually, I have two questions, and one, sorry, it's for Margaret. I had to go for a phone call, so I got one in the back here. So first for you, Margaret. This is from Marcelo Morandini. He says, what's being the marketing quotes, activity that you are doing to achieve the higher number of people registering their DOIs?
I can do it from here. So we call that outreach. Basically, as a repository, we go to meetings, usually large meetings. Like an important one for us is the Ecological Society. There's one in the U.S., Europe. Partly because those communities of researchers are fairly, I'm going to say, isolated. They work in small labs. They don't typically use large data sources like satellite data, so they don't have a lot of exposure to what's already going on in the community. So we really feel like we need to entrain them and get them, entrain in a oceanographic sense, pull them into the current and get them kind of up to date on what we can do and what we can do to help them. And so actually some of the slides that I had this morning, the one where your data is disappearing over time, those are ones that I give to ecologists, because those are the people who still have their data on tape. And they're all retiring, and they're, she said, looking at Allison. I've done some of Allison's data already. So that's the easiest way. It's slow because it's one-on-one. But we tweet this kind of stuff pretty regularly. Actually, EDI, our repository, has a Twitter engine that every time a new data set goes in, a tweet goes out. And after a while, people would stop subscribing to it because it just was too much happening. But it's there. I mean, that's a pretty easy way to do it, just to point out that this happens a lot. Those are probably the simplest ways, but they're, like I said, going to meetings is expensive and time consuming, and you only reach one person at a time generally. Thank you.
So thank you very much. This is another one from Marcelo Morandini. First of all, he tells Caio and Pedro, very good presentation, and say that you, Caio, and him should work together to improve the usability issues of this tool. So, message given, Marcelo Morandini. And then the question is, where is this question? All right, so he says, I know a little bit about this tool. Can you talk a little bit more about how the tool allows using different metadata patterns like Darwin core, Dublin core, etc.? This is the question.
Can I take it? Yeah, sure. So actually, we are developing a way to use schema.org or something else that is already there and not doing a new type of differentiation in between the types of metadata. So we are trying to see if there's a way to do not develop many strategies to handle different types of metadata, and trying to use the JSON LD from Google datasets, and which is based on schema.org to make this one thing only to show metadata here. We also can develop some transformers from between those types of metadata to JSON LD. But the JSON LD from Google, which is based on schema.org, is the preferred way to show metadata.
Green. What that means is that the responsibility for mapping to the schema.org schema belongs with each of the repositories that want to see their data go into Google. So like if your repository runs in Dublin Core, then it's your responsibility as a repository to make that little bit of JSON LD, tuck it in each one of your web pages, and then Google can pick it up. So that means that people who use the Google schema.org don't have to do it themselves. It's done by the repositories. So they're the only one that have to understand the metadata schema that they use, because there's about a dozen, I don't know, it's a lot. Okay, thanks.
Thank you.
Other questions? No? Online? No? Okay, thank you, both of you. And now this is time for the session on dataset compatibility. So that will be presented by Alec Bajarski and Jesse Joe Rigo. Hope I'm not too bad on the pronunciation. From Oregon University, and also by Alison Special in the second part. Pleasure.
Jesse Joe, I'll let you take the mic here. Okay. And they'll pull it up on the Google Drive. Okay. It's on the shared drive. Okay. Somebody knows.
It's up a little high for me.
Okay. Yeah, how do we use this device here? Give us a lesson, Jeanette.
Left, right, and
Yep.
the lace.
Perfect.
Thank
you very much.
Thank you.
Go ahead.
Okay.
I can click for you if you wish.
Okay.
Unless you want to.
Okay. Welcome. You're right.
Yeah,
Just
yeah.
stand. Okay. Okay. Hi, everyone. Can you hear me? Hi. Hi. Yeah, thanks for tuning in. I know we're getting late, so everyone's probably getting a little tired again.
But yeah, so I'm Jessie Joe. I'm one of the research assistants on the PARSEC project on the US team, kind of studying under Jamie Trammell. I'm also a master's student at the University of Nevada, Reno. Most of my work is involving policy or socioeconomics of some sort or water policy, so I kind of do different stuff than what most of you do here, but I'm really excited to talk about our sort of global socioeconomic indicators process that we've had during this PARSEC project. And yeah, I'm gonna let Alec introduce himself really quick.
Some teamwork happening up here. Yeah, I'm Alec Bayarski. I'm also a research assistant on the US team for the synthesis science branch. I was a student of Jamie's as well, have since graduated, but my background is in environmental science, GIS, and I'm looking at socioeconomics now more through the lens of fire recovery. So once again, a little different than all of you, but related as well, right? So.
Yeah, and so today we're going to talk about choosing socioeconomic indicators for protected area evaluation that are globally and nationally relevant. And I'll give a little bit of background since Nicole asked such a perfect question for us last time. And we didn't plant her, but might as well have. So when I first started on the project, I asked a similar question. I was like, well, what skills do we all have in common that we're collecting socioeconomic data at? And sort of what kind of compatibilities do we have across our 5 PARSEC countries? And so a while ago, Alec and I started working on a literature review and looking at those scales and kind of starting to parse out what sort of socioeconomic indicators and things we have in common across the 5 different countries. And so since then, we've kind of been trying to figure out how to look at this challenge and how to find something compatible across countries. And so now, this is sort of where we're at with this paper. So yeah, so now we're using the Convention on Biological Diversity, the CBD goals, as sort of our global framework to address this problem. And we're specifically looking at this strategic goal D, target 14, which is looking at ecosystem services for the benefits to people. And so, well, I'll talk about it in a second, but basically this is kind of our backbone for this paper and the basis of that overarching global compatibility that we may all have, because the CBD goals are sort of the, like, not, I don't want to use that word. The CBD goals are basically our agreed upon conservation goals that we have as globe, I guess. And so that's kind of where we're starting, and then we're going to work our way down through the literature review that Alec and I did, and then sort of what our PARSEC countries have discussed as far as indicators that we could use. And so, as we've all experienced, there's kind of a lot of challenges with selecting indicators that appropriately grasp how a community may be impacted as far as socioeconomics goes when protecting land. And so, like I said, we're going to be looking at global goals which motivate this sort of common approach. But selecting indicators can often be really like country context specific, and so that's why we've even in PARSEC had kind of issues choosing which indicators will be best for us to all use. And also we've used in the past for evaluating protected areas more output and activity-based indicators versus outcome-based indicators, and I'll give a definition for those in just a second. And so yeah, so basically what's sort of motivating this paper is how do we address the different needs for selecting indicators for monitoring and evaluation purposes versus more targeted evaluation research, which is sort of what we're doing for PARSEC. And so our research question for this paper then is how should evaluation researchers consider trade-offs across 4 factors when choosing socioeconomic indicators of benefits to people? And so the first sort of component to this is whether it's relevant to a global goal. The second is whether it's appropriate at a national socioeconomic context level. And then whether it's a quality indicator for actually assessing a benefit or the benefits to people, and then is it available? Is the data accessible, and can we actually use it and collect it? And so, yeah, we'll be assessing that, a variety of indicators based on whether they're an activity or output, which would just sort of be like a conservation program, whether it's an intermediate result, which is sort of an outcome, but not necessarily like the main outcome that we may be looking for as a result of protecting areas, and then an outcome, which is essentially well-being and actual benefits to people. So I think this is...
Thank you very much. I'll swap. So, specific aims and methods for this paper. We're going to be using data, as Jesse Doe mentioned, from our different countries and teams here with PARSEC, and we want to understand how countries are reporting progress on this specific CBD goal, Target 14, and we want to characterize those indicators based on what we just mentioned. Is it an activity, an output, an outcome? We want to review the socioeconomic impact evaluation literature to identify the indicators used. So rather than CBD indicators, when we read literature on this subject, what indicators have we seen used in the past, and how are they using those to assess the impacts from protected areas? We want to synthesize the findings from our different teammates here on the data availability and what indicators they find to be nationally relevant. Because as mentioned, we're all having different struggles finding data that's available and figuring out what works in our own specific contexts. And taking those three together, we want to try to assess the trade-offs of using certain indicators versus other indicators, which ones are good for what, and hopefully use that as a way to make recommendations for researchers in the future so they can have an easier time selecting indicators as well. And finally, we want to reflect on where the countries are and their potential to use indicators that are more focused on outcomes, so what the specific outcome is to the people that are local to the protected area, rather than looking at a certain activity or an output like, less deforestation or maybe higher conservation, but how are people affected, right? Actually, back to you for this one.
Okay, yes, now it's back to me. Okay, so just we'll run through quickly some sort of preliminary results that we've collected. And sort of to answer Nicole's question also, so we looked to see if there was sort of a database or an organization that may collect relevant indicators that that our countries could use that are at a compatible scale and also available. And there's not necessarily anything like that we have found for PARSEC that we've been able to use. We've talked about the DHS, but obviously that's kind of lacking in the country context specific area when it comes to being an appropriate indicator. So first, we decided to look at the CBD goals and whether each of the 5 PARSEC countries has a Target 14 ecosystem services for benefits to people goal, and what indicators they're using at that national level to assess progress towards this goal. And so, we've got listed here Australia, Brazil, and France, and our next slide will have Japan and the United States. It's kind of cut off, but this says that for Australia, they listed several national programs that they're looking at, which sort of target this goal, but they weren't necessarily created solely for that target. So it's not necessarily a direct measure of that progress for that target. So we've classified that as an activity or an output. And then Brazil and France had similar statuses of their progress towards this goal as well, but obviously different programs, which are, results like listed here. And we've categorized those as intermediate results because they sort of evaluate progress towards that goal, but they're not necessarily getting at the direct outcome that we were looking for. And then Alec's going to talk about these two as well.
And so for Japan, similar to the rest of them, they have this target goal for themselves, but they're making progress not quite at the rate that they would hope to achieve the target. And that's also an activity/output or intermediate result. So indicators looking at relevant inputs and activities, but not quite the outcome to the people that are affected. And the United States is a little bit different, as we are not part of the IHE targets or have not signed on to the CBD goals. So our most relevant piece of legislation at the moment is actually from 2021. It's Executive Order 14008. We usually refer to it as 30 by 30, so trying to conserve 30% of our lands and waters by 2030. So specifically sections 214 and 217, it uses some similar language. It focuses on indigenous communities, people of color, marginalized populations, so looking at the activities or the impact to local communities from protected area use. So it's about the closest we can get to compare. And it's going to be hard to measure progress on that as it's so soon, but something we can use to kind of take a look at progress is the National Ecosystem Services Partnership. And they're starting to look at more relevant ecosystem services so they can look at the impact to humans. So the example shown up here is rather than a change in nitrogen concentration, how does it change the number of swimmable days? So the effect to the people in the area, not the effect to the water in the area. And that's more of an outcome, but as I said, it's not perfect because it's not quite measuring progress from our legislation, so we've got some work to do on that. And so this is a table showing results from the preliminary literature review that we did. It was quite a while ago, but rather than looking at indicators used currently to measure CBD goal progress, it's looking at previous literature that was looking at protected areas, how they're impacting local communities, and these are just the topmost, the indicators that we saw used the most in the literature. So it's things like poverty rate in percent, educational attainment, employment in ag, forestry, and fisheries, poverty distribution, and total population, median household income. So these are the most common indicators that we found in literature, and the goal now is to compare that with indicators that are listed as measurements for progress on CBD goals, and hopefully use the two of them to make a framework for suggesting how to choose indicators moving forward. Jesse Jo?
Yeah, and then, so we kind of have like threefold results here, but essentially, like Alex said, we'll be comparing those two, and as you can tell, those were obviously pretty different, so it's like a little bit interesting to see that in journal articles and in targeted evaluation, we're picking those indicators on the last slide, but then at these national levels, reporting on global goals, we've even still all use different indicators, which are not even the indicators found in the literature review. So there's a lot of discrepancies going on there. And so what did PARSEC use? What have we chosen so far for PARSEC? And it's also all different. So this is a while ago, we had asked each of the countries to sort of write up a little paragraph for us on their process for selecting socioeconomic indicators and what indicators they chose. And this is what we have so far, and we'll hopefully get to add to this soon because Allison just found some for Australia. And so, yeah, I'm not gonna go through all of these, but essentially each country chose different ones. They're all from different data sources. They all are relatively more country context specific than comparable across countries. So yeah, but there's obviously a lot of trade-offs that we'll be able to discuss in this paper, and I think I can actually go to the next, and talk about. So obviously we've all got different interpretations of these global goals, and I think the goal of this paper essentially is going to be talking about the trade-offs between picking accessible and available data that's maybe more granular or easy to find at a variety of scales across countries, which is usually something like poverty or these more evaluated indicators. But something that we've really been talking about a lot in PARSEC is there may be more to the picture. And so what are the sort of trade-offs of picking different indicators that may be not as globally evaluated, but more country context specific, or available at more granular levels or less granular levels, and what are all the trade-offs happening there, and how can we kind of use this as a framework for going forward and doing these larger projects to have more compatible indicators and a better idea of what we're gaining and losing from choosing certain indicators versus others. So yeah, I think we're, and you want to wrap this up?
Sure. Okay. If I can wrap us up. So the final steps. We want to finish the policy analysis, looking at the different CBD goals, the different indicators used to assess those, and how we can mix that in with what we're looking at with PARSEC to make something usable across the countries, right? We want to continue working with our different teams here so we can get input on the relationship between data availability, global goal reporting, their literature reviews, and figure out how we can all look at that together to synthesize a better framework for choosing indicators that are useful for our goals. And we're hoping, like Jesse Joe keeps saying, to figure out the trade-offs between using certain indicators rather than others, and ideally come up with a bit of a framework to help future researchers have an easier time choosing indicators that are more effective in actually assessing the effects of protected areas on the local communities. So I could spend another 10 minutes thanking everybody involved, but I won't. But everyone in PARSEC, all of our funders, everyone here hosting us and joining us online, we really appreciate the opportunity to be a part of this work, to be here speaking with you all, and to have you here at the end of a very long, data-heavy day. So thanks to everybody, and any questions?
Okay. Yes, we've got, yeah. You pick. I don't want to pick.
Who first? I didn't see. How could?
Sorry.
I know, we're all surprised. All right, so my question to you is, so this answers parts of the questions that I asked yesterday, but now you've done all of this work, and we're seeing a lot of discrepancies, and this does not surprise, I think, anybody in this room, but my question to you is, then what are you going to do? Who are you going to tell this to? Which groups are you going to bring together? How are you going to find ways to help harmonize this? Who are the policymakers, or who are those global groups that you need to influence in order to make it easier for the data that you need to make the research more easy to take forward? So I guess it's more of a challenge than a question. I mean, you're welcome to try and answer it if you know the answers, but I think I would challenge you to think about the data that you have collected and what it tells us about the data that we need in order to more effectively do this kind of research, and who do you have to influence, and how are you going to get into those rooms and talk to those people? And that is, you can try and answer, or you can just leave it to Stu and we can talk about it later.
Do you need? Okay. There is.
Oh, that'll probably be easier than you running. Okay, is this that? Yeah, I can hear it. Okay, yes, that's really, yeah, that's the challenge. Yeah. I will say, I think something I'd really like to see out of this paper is maybe like kind of a call to action for researchers and also evaluators to really think about to really think about what exactly we want to assess, because I think that this whole mechanism piece of how protected areas actually impact communities is often lacking in our research. And we kind of see this because why are we picking all of these different indicators if we want to study the same thing? Are we actually studying the same thing? And so I think what I think would be really important about like maybe just producing this paper is at least being like, we really need to establish how we actually believe protected areas are affecting communities. And once we've established that, are we picking the correct indicators that are going to address that goal? And, if we're going to scale up, where do those trade-offs start occurring? And, I don't exactly know who we would elevate that to, but yeah, yeah. Yeah.
Here, hello. So this is another one from Marcelo Morandini. Great presentation, again. Thank you, Jess and Alec. Can you tell how hard it was to analyze these so different data from these countries? Could you comment on that?
How difficult was it to analyze the data from the different countries, being that it's so variable?
Yeah. Yeah, it was pretty difficult. It was difficult just because we kept finding out that there was more and more differences than we were expecting. And so like even doing our literature review, it was like, oh man, like there's a lot of countries who have looked at this and find this really important and are trying to figure out how communities are impacted, but everyone's using a different way to approach this and using different indicators. And we definitely ran into that issue of trying to read papers, but they were in languages that we don't understand. Even going through some of these country reports for the CBD, which is really quite organized, and they've got it laid out by country, and they have annual reports that are published. You know, we even had issues with like, oh, this country hasn't published the most recent version, and so now we have to go try and find their indicators in a, you know, from a different source. So that wasn't the biggest issue, but yeah, it was, yeah, there was, yeah, a lot of challenges. Do you want to say anything?
No, I think we better let our next presenter come up, but we're happy for more questions later.
Sure. Many thanks to both of you for this promising work.
Thank you.
And before listening to Alison and to Jeanette, I think, we have a little special moment for the awards regarding the students. So at the end, so it has changed. Okay, as you like. Is it now or is it later? Later on, okay. So then, just let me know. Okay, so the students first. So may I call Pedro for the students?
I've got to talk.
So
do you want to
before
talk?
Jeanette, there is
Yes, if you want to do now. Okay.
I think Alison is.
Very short.
Yeah. Okay. So this is your.
Okay. Maybe yes, I will. So I've just got the second half of that talk. So that's why I'm.
Which is yours?
Mine says the time, and the time is 15. This one. Yeah. Ah, that should have been 20. Oh, there you go. Okay, this is the second half of that last talk. So, yeah, it should be quick, and it will be quicker, because it's not this one, which is much more expensive, much more difficult. So these two talks were about data set compatibility, and it was largely so that everyone here could understand some of the incompatibilities related to scale and that sort of thing. The previous talk you've heard about that Jessie, Joe and Alec did very well, that has been really getting deep in the weeds with that, as one says, for quite a while. One of the most successful papers that we've got, because they've really been getting into it. Part of that is because in PARSEC we are dealing at a very high level, or at least we started dealing with socioeconomic variables at a very high level. Most socioeconomists work with a survey, they go to a village, they interview people, they do graphic diagrams and lived experience stuff, and that's the sort of socioeconomic variables they collect. Sometimes there are different scales, but not as often are there big scales like ours, at least looking at protected areas, which is remote sensing. So we've relied a lot on census data, which is partly where this disjunct that Alec and Jessie Joe have been wrestling with. So there you go. You go, bridge, segue. All right, so the data set compatibility for the WDPA. This is the other one that we've been wrestling with from the beginning. But when we realised, and some of you might have heard, when we realised that David's idea at the beginning, and he's admitted, yeah, it didn't quite work, that people think the World Database for Protected Areas is going to be a standardised, uniform, large database. And there are others around. The DHS for health and welfare is a similar sort of database. We've got others like GBIF, which deal with biodiversity data. They're big databases that the countries of the world collaborate with to produce. And the reason why? The reason why is WDPA, for example, is used to benchmark a country's achievement in conservation goals. 30%, 50%, 10%. How are you going compared to the Rio Protocol in 1992 or later ones. So it goes back a long way that this sort of thing happened. Okay, so from our point of view, can we rely on the WDPA for our purposes across countries? Remember, fit for purpose. WDPA might be excellent for some things. We have our doubts, but because we've had a day thinking about that. But across our countries for our project. We know that the WDPA is built from country data. The countries supply the WDPA with the data, or so we think. They may not always. The WDPA may have to make some up, or at least work out an estimation. But we are making in-country training decisions. So Ali and Janeth are looking at a protected area and through satellite imagery, night lights, whatever, within country. So if there is any discrepancy between the WDPA and the within country data, it could matter quite a bit. And does the WPA supply that sort of granularity? You'll hear that word quite often, that is required for this. Okay, so there's a little table I will skip over, but this is because this is what we've been working on, same sort of thing as Jessie Jo and Alec and the team with the socioeconomic stuff. First thing, get a table together with some headings and try and work it out. So these are the different suppliers in each of our countries. How we create it, the link to WA. What actually is the workflow? And it's quite an interesting one. There's lots of within-country, between-country workflows. That's quite interesting. And we'll talk about that in a minute. Now, I'm going to use two examples because I'm actually speaking largely on behalf of Katja Ferraz, who had to go, and myself. So you're not just hearing from me yet again. Katja and I are talking, but Katja had to go. So here, for example, is the classic IUCN World Database on Protected Areas versus the Australian government supplier of those data. And you can see immediately we have 11,149 total protected areas registered in WDPA, and I think I've touched on this before, and more total protected areas within country. What happened to the ones that disappeared? Why did they disappear? That sort of thing. So we have been looking at that. This, by the way, is our RMesh blocks from the census, which is the national data that's collected every 5 years. You've seen that before, so I won't touch upon that again. And that you can't see that, so who cares? But that's the sort of granularity we've got in measurement of measurement of the human population. It's cut up according to population density in Australia. The census areas are cut up according to population density. They are not cut up that way in Brazil, for example. So they're cut up in a different way, different population densities. So, and this was how my colleague from Oran made this map, was at the socioeconomic level. So it's interesting. We're having discussions about how to represent this. This is the difference in area measurements between WDPA and CAPAD according to eco-region in this case. So this is something that I'm much more interested in, is eco-region here. And you can see there's a hell of a lot of difference, 200% difference for some eco-regions in the area that's recorded in the WDPA versus the CAPAD. I would argue that the CAPAD is usually right. If I talk to the person in Australia who is responsible for this, and he may listen, he will say, oh, I have a terrible time getting it from the States to me. So you've got a workflow that goes from supplier to supplier. That does create challenges. Okay, so this was something I think I showed, maybe I didn't show before, but for example, for my actual town selected, I had for 35 towns, that's all it is that are related to a protected area. Of the protected area they're related to, quite a large proportion of the PAs weren't actually in the WDPA, those ones that disappeared, but they were quite respectable, bigger than the 1 kilometre squared that is our minimum, and IUCN 1 or 2. Some were very good, they're exactly the same, great stuff in area. And, in date, sorry, these were dates. This is dates, sorry. and these are dates that are older. So, for example, in Australia, they happen to transfer the latest mention in the Parliamentary Gazettal about a protected area as the date, or as a status date. We, for PARSEC, initially interpreted that globally as the date of creation, which was quite important because we want to know whether you could get satellite images before and after creation. There were a number of particular protected areas that were gazetted according to the WDPA as it was within our date range, which was 98 to 2005, that were actually created, and the largest area of them was created in 1903. So a vast difference. Very big error, we couldn't use them. But until we get to the country data, we didn't know that. And I was going, this is all wrong. I'm looking at the blogs on the, so there are some interesting things. In Brazil, same sort of story, exactly the same story, slightly different. One of the problems is language. So protected areas being counted twice, not because they go over a boundary of a census area, be it eco-region or census area per se, but because they had an Indigenous name as well as an English name, and the people at whatever it is, conservation, what was it called, you two? The people in Cambridge or wherever it is, who's a lovely woman, they didn't recognise that they were actually one and the same thing. So suddenly Brazil's got a third as many parts because of a different name, nomenclature. So that was interesting. So little things like that. So we ended up with identified problems. So that's what we're going to hierarchicalise these across the different countries, and we think we've got a paper and a story that will be of value. What do you do with these big global data sets? There have been a few, they're fantastic, no, they're terrible, oh, they're fantastic, attack and defence. So we don't want to add to that, we want to be constructive. So that's about it. Here's the commentaries, for example. It started, really the track so far that we've seen started with a man in Australia who wrote, "There's flaws in the WDPA, this is terrible." Needless to say, by 2000, that was 2013, by 2019 he was an author of the paper with the leader of the WDPA. So she brought him in, which was good. And what did it say? 60 years of tracking conservation progress using the WDPA. Yay! So so that was interesting. Turn an attack into a justification to improve, and then write a paper. Good stuff. Then wrote something, pitfall of big databases. We're quite interested in that. You have to harmonise. You have to standardise. Do you lose stuff? Is it important stuff? Okay, maybe fit for purpose, we go back to the source, in which case you need to know the workflow somewhere. So you can go back to the source, you can find a link, and that was something we must write down on our notes. Find that link. How was it derived? Then, of course, he wrote that one, and then Elson, this guy here, said, oh, no, it's not that bad. So you've got attack, defence, which was rather amusing. We haven't got many papers, but we found another couple on top of that. So that's it. Thank you very much. Now it is whenever you want. Thank you.
If there are any questions for Alison, this is the one. No, yes.
Okay, this time I think it's an easy to answer question because it's a really naive question. So over the course of the last few days, I've heard the words cleaning your data mentioned many times. Is this what we mean when we're talking about cleaning your data? I think I know the answer, but I just want to be sure that I know the answer.
Yes and no. Yes and no. It is not our position to clean the data from the WDPA, it's their data. They've made certain decisions, and that's a bit the same with the socioeconomic data that I had up recently that we're going to share soon with this group, that a committee and lots of eminent people have got together and made a decision about this variable or this variable for one reason or another. Is it fit for purpose for us? Yes, maybe not. So I wouldn't call that cleaning our data. Margaret might I'd have a bit more to say upon that because, yes, so what we normally do with cleaning data is work out errors in the entry or something like that. We're not really looking at that. It's probably something we don't have a right to do because it's theirs, but we can make a comment that perhaps for this purpose, which was ours, you could have taken this. I don't know if that's a helpful answer, but that's what I would say.
Very similar line. And I guess the question then follows, which is, so then how do you fix the data, right? So because it sounds like what you're saying is, the data is wrong in there. It's not my data. I don't get to fix it. But who gets to fix it? And do you push back?
Yes, you're right. What we're going to do is, what I've done with the Australian mob, these people from Oran, is say, right, for this parameter, we are using our data. For this parameter, I'm happy to use WDPA. But we're probably going to end up using the in-country data and say, well, we know this is true, for in-country analyses. What we do about that when we compare countries and do the intent of the WDPA, which is interglobal, international comparison, is going to be an interesting challenge. So we're increasingly retreating for socioeconomic reasons, for WDPA reasons, and a couple of others, away from cross-national. For practical reasons. I shouldn't say this in front of the Belmont person. But for practical reasons, we hopefully will come out with some relationships that are translatable and across the countries. But yeah, we've been making a fix or saying we'll use this variable for this parameter and we'll keep on using WDPA variables for another one or something like that. So it's not really cleaning, it's mix and matching. You know, red cardigans versus blue.
Is there a WDPA feedback loop? So are you going back to the WDPA?
Yes. That's quite important, and it has to be done delicately.
Many thanks, Alison. So I think now we are listening to Jeanette.
Okay. And what is?
Who will talk about reproducibility of deep learning experiments.
Yeah, thank you. So we are hopefully made it until 8 minutes so that we have finished. I'm trying to be the more shortened that I have. I'm going to be my best. So this is about reproducibility and especially for deep learning experiments in general in science. So before I'm showing this, I was just remembering myself as a researcher that has just begun with any kind of topics. So when I'm speaking now, maybe it's for the students or for the people that is going to a new field that is he needs to, or he or she needs to try to reproduce whatever code, experiments, papers that they have faced and how he can overpass it and learn from these papers. Okay, so when we see that typical research pipeline, we see that this is for academic especially, but for instance, we have any kind of scientific problems, and we are both as an author and as a reader. Okay, we as researchers, we write papers, and we also read it, right? So we are both, maybe we can do these both profiles, and we have a paper, right? So, but here we have also the reader that it's the one that replicates or reproduces works from another ones. We have the writers that, of course, it's going to report some experiments and whatever. And we also have another profile, which may be the reviewer. Okay, so the reviewer is and also the reader that are just trying to reproducing other papers. So, but you may wonder these things. Have you ever, and I'm asking you, have you ever tried and failed to reproduce another scientist's experiment? Okay. Yeah, you are not alone, okay? You are not alone because this has happened because of the many difficulties in several, especially in computational experiments where it is hard to understand. There is many incompatibilities with the source code that we have. The data is maybe not the same availability. We have problems with the settings with the computer, not the specifications, not libraries, not versioning of this, and most of the problems, unavailability of codes. So reproducibility in modern science, it's a challenge. And these are the numbers. That's why I'm saying to you that if you have struggles with reproducing any kind of experiments, you are not alone because this happens a lot. And in recent studies, the researchers were unsuccessfully to reproducing other people's experiments, almost 70%. So this means a lot. 50% of them couldn't reproduce their own research. So for instance, myself, I'm trying to reproduce whatever experiment from 5 years ago, I'm not able to reproduce anymore. And of course, 86% is reluctant to share code. So many people is not making papers with availability of GitHub or code or repositories or wherever. So this is an important number. And this doesn't happen only with general experiment, but also with Jupyter notebooks. In this, for instance, there was a paper where showing that from 800 Python notebooks, more than 800,000 notebooks, more than 24% were able to run without errors. So when we run some code, Jupyter codes or whatever, Jupyter codes in this case, they were found, most of them without errors. So the 80% that is missing has been errors. From all of these, only 4% produced the same results. Only 4%. That's an incredible number, so that we have to face this problem of reproducing any kind of Jupyter notebooks. And from all of these 86% that were not able to reproduce the same results, who have failed, 50% of these codes has different results, and more than half of the notebook. So if we have one Jupyter notebook, we only could run only the half of this, and we couldn't have the same results. And also there is other plots that I'm not going to explain now, but so that you can figure out how huge is the problem. And when we are talking about reproducibility, we want to make sure what is the term, the correct term, which is reproducible. It has the same analysis on the same data, and replicability, it's on the same analysis but different data. Okay, so this is just to make sure we have the same good terms. And in deep learning, these problems with computational experiments are even more challenging. So besides the difficulties from having computational problems and issues, we have plenty more when we're speaking about deep learning. For instance, when we have a huge volume of data set, the misspecification of the model, the training, the hyperparameters, insufficient description of the experiments, suitability of the software environments, libraries and versioning, and also architecture and hardware of the setup for the configurations. Why this happen? Okay, in deep learning, it's because of the variations. So in this work from Renard, they have shown many of these variations and why it happens in deep learning. It happens a lot because of the data set. If you've changed just a tiny bit of the data set, you're not going to have the same results. You are maybe getting overfitting of the method. If you have changed some of the parameters on the optimization, also you are going to have some other issues. This happens also with the hyperparameters. If you change the architecture, you're never able to run even the experiment. If you change the infrastructure as well. So we have plenty variations that could lead not to get the results that we want. So we are going to get different results, and this is not reproducible. Okay. So if we were wondering how then I can reproduce the problems, experiments. So we have published a paper that is trying to help you as a researcher not to waste some time and by doing just to take the short path to get reproducible of experimental and with deep learnings. So in this paper that it has been recently published, and you can access here, it's open access. It has two advices for two kind of people that want, of course, everybody's welcome, but if you're a writer or a reader, you can use this checklist, which is a compiled checklist, so that if you have seen your code, you have to check each by one to make it reproducible and to guarantee that anybody that is reading your paper, it's also has to be check this passed checklist. So for instance, we have regarding the data set, if it's complete, about the FAIR principles, if they are findable, accessible, interoperable, and reusable. We have seen this all this week. Besides that, the description of the architecture, if it's complete, or the hyperparameters and the specification of the parameters. How well described is the infrastructure and implementation, how well the reported experimental results and theoretical claim are the same that the code has shown, and if this paper experiment is sharing code. So we have this checklist. Of course, they have plenty other questions, but this is in summarize what this is the checklist. And if you are not, you are only trying to reproduce other works, we are here compile the most frequent issues with deep learning experiments, which are these four. One is the most issue with the quality of the data set. And the second one is about the deep learning experiment, then the implementation infrastructure, and about the FAIR principles. So here, if you are going to the paper, you are going to see which are the mitigations to get, or how to do, if you have faced a problem regarding the quality of the data set, so then you can go and check what you can do. For instance, an example, if I downloaded a data set from a paper, then I can first validate if the data set is complete, if you have to make some analysis, if you have only to check one sample of the data set, to check parameters of the data set, some pre-processing step or data sampling. Whatever you have to do, you can go for this paper and check it with whatever issue. This makes some recommendations for you. The same is with the deep learning experiments, and this is regarding the hyperparameters. So if you have to search for another, for instance, to looking for workflows, to see which are the steps to running an experiment, to see for the model architecture, to see for different setups of experiments, and so on. So I'm not going to pass all of this because it's our paper. It's more specific with a recommendation for each of these if you have faced some problems with these points. So what is most important here is that, I'm going to pass here. This is what I want you to take as a message from this, is that if you want to improve reproducibility, in order to achieve the full replicability of a problem, which is the goal of modern science, If we cannot do that, at least we achieve reproducibility. Okay. So that we can ensure open science to make more accessible and to progress scientific community research, right? So my message for you is first create, of course, you are going to create new models, new techniques, you are going to publicate and so on. But then you can't assure that this has to be replicated so that the persons that is going to follow you improve reproducibility as well. Okay, that's it. Thank you. Sorry it was short.
Many thanks, Jeanette, for those very, very useful recommendations. Do you have any questions or comments? You're tired. You're hungry. No? Okay. Well, then I think it's now the students' moment. Yes. And I will invite Felipe to chair this important moment. You're doing this so well.
Hi everyone, look who's back. Who would say it? So, I'm here again, this time to give the best poster award that we have. So, we had a very good group of reviewers that helped us to reveal all of the 12 works. And today we have 3 best poster awards to give to the best posters. So, the first best poster award, Rosa is going to give. Rosa is going to give to our amazing PARSEC queen. So, the work title is Deep Learning Methodology for Predicting Socioeconomic Indicators in Vale do Ribeira using Satellite Imagery. Come here, Isabella! PARSEC queen, PARSEC queen. Do you want to say some words?
I didn't know I was going to give a speech, but I would like to thank you very much for this award. It was definitely an honor to present my work here among so many brilliant other projects, so to disseminate knowledge, and a pleasure to be here today to receive this award. Thank you very much.
So, for our next best poster award, the work title is Evaluation of Machine Learning Models for Species Distribution Modeling in the Amazon. Sadly, the first author is not here right now, it's Renato, but since I am the second author, someone can give it to me. I don't know. So just a quick speech. I know Renato since he was a kid. I even changed his dippers. No, just kidding. But Renato is an amazing student. He's not even in the Master of Science course yet, but he has already a lot of promissory works, so I feel very proud of him. Just to For our last Best Poster Awards, it's the same thing. But in this one, I think that it wouldn't be so nice if I receive it again. So, Janeth, come here to receive the work, since you are... Oh, where's Marcio? No. Marcio had to lead like half an hour ago, so I need you to receive this award. Come here. So the work name is called Characterization of Deforestation, like twist my tongue, patterns in the... Wow. That's it, everyone. It was an amazing awards section.
So I think that means you need to pick up your award again.
Stage it up. So first our queen. So individual.
The queen in the middle, please.
That's you. Your core element. Okay, now together, please. All are on the front. And in front of the lovely. Yes, there. Very good. Very good. But squishy more. Squishy more.
Still need me or no?
Yes.
Checking.
Remember, you're important. Now that you're shaking, when I just said that out loud. Very nice. Okay.
That's it.
Solange and I just sent an email to the SOR platform with all the posters list to the put in the platform available. The platform is really nice, and the DOI it vinculates with your seed in the same day. It's pretty fast.